All right, cheers everybody. Exciting day over here at Future Cannabis Project 2. We have Ty Guy Grows High. He came at me a little while ago, really interested in being able to get some of this information out. Mark Boutwell's been out here doing some amazing work in the community, and he just got done doing some new research on his drops of balance. And so we're going to be talking about that, talking about a lot of different molecular structures of these things that we're feeding our plants and how they're uptaking into it. So without too much more, I'm going to allow Ty to introduce himself and why he's interested in chatting today. So hell yeah. Cheers, everybody.
So yeah, Ty Guy Grows High. If you guys don't know me, I guess probably talked to lots of you in chat anyways, but those of you who don't, Ty Guy Grows High. So yeah, I've been following Mark for a couple of years, and he's got some like really interesting research on chemistry and the molecular structure of synthetic nutrients versus organic nutrients. And correct me if I'm wrong, but you described that they maybe are metabolized differently or metabolized in the soil by the biology differently.
Well, it's what we're dealing with is actually extra chemistry. And when you have too much chemistry, it just becomes extremely overwhelming for the soil biology. A lot of the fertilizers all fertilizers that are made, pretty much they end up, the goal is, I don't know if this was the goal, but the goal, how I look at it, is it ends up being the goal for the scientists to replace the fungi and the bacteria, right? But the key difference is that the scientists are providing a water soluble salt that skips like your entire filter process. Versus bacteria, they go through a 24-hour enzymatic production cycle that makes the rock water soluble and makes the rock into a salt. So what ends up happening is the bacteria obviously are incredibly efficient. So they're going to create something and complete the chemical reaction within that 24-hour cycle. So it is extremely efficient for that plant to take it up. The scientists create molecules that has additional excess chemistry that ends up, first, if it's too hot, ends up making the soil biology dormant, and then second, ends up creating an environment where the soil is going to need to detox so that the microbiology becomes active again.
Okay. So do you think that there's maybe like some of these heavy metals are like a byproduct of some of this extra chemistry?
Absolutely, and I'll just refer occasionally to the report. That's what this report. First, this report is the first of its kind in the cannabis industry, and I would say the first 10 of its report worldwide in agriculture in general. So it's when we say leading edge information, this is the leading edge information. It's what this report was really to discover the detriment to. I'll back up. This report was really about, can we remediate pesticides, fungicides, and heavy metals out of the soil and or off of the plants before harvest. That's what this test was ultimately about. And we had a hypothesis that these heavy metals and pesticides and fungicides were hindering the nutritional value and the overall quality of the product, but we didn't have statistical or measurable data to prove that exactly. We just were pretty sure, because we use a pesticide to save us against the bugs, right, from hurting our crop, but we don't take into consideration, I mean, we are a little bit, the taste, other things, but we're not totally sure how does that actually affect our yield or the nutrient density of the food in general.
Definitely.
Did I answer your question?
Oh yeah, definitely. Like, yeah, there's extra stuff going on that doesn't need to be there, and it's putting stuff in there that doesn't need to be there, basically, from what I gathered.
Then what ends up happening is the soil actually starts to activate enzymes that initiate powdery mildew, botrytis. They actually start initiating more bugs to come eat the plant, because these enzymes, which the plant is is, or the soil is meant to activate just at different times, right? At the end of the season when the plant needs to decompose, but it's starting to activate these enzymes earlier in the plant cycle.
Okay. So
before we get going too much further, we have Matt. Who's the other gentleman? I'm sorry, that will be involved in the conversation before we get too far along. It's Matt and Gardy. You want to
Matt and Gardy? They are two of the finest friends I've had, and now we're going on almost 15 years of working relationships. They are the foremost experts on using these minerals, probably in the United States and most of the world, and they've been contributing to Drops of Balance to the brand now, like I said, close to 15 years or so.
Awesome.
Matt, introduce yourself, brother.
Hey guys, my name's Matt. Yeah, I guess I'll go from here, being called in. I've basically been working with these minerals for about 20 years. They're manufactured out of Japan. And essentially the creator / discoverer, entrepreneur was a chemist that worked in nuclear chemistry and how to clean nuclear wastewater. His name was Shimonishi Isao. And his identification of the stone came from basically one day he was on the beach and saw a tree growing out of the rock in the middle of an ocean. And he's like, how is this tree growing in a rock without soil? So what he did was he looked into the actual formation of the rock itself, and he found that this specific stone known as mica, and usually surrounded by granite or within granite, which is also a mafic eruption, the lava formation of an eruption in a volcano. And what you get is you get all aluminosilicate. So when you hear the word aluminosilicate, it doesn't matter what aluminosilicate you heard of, it came from a volcanic eruption or was formed by volcanoes. And so like clays, bentonite clays, all of these things. Well, the black mica, which happens to have the highest concentration of trace minerals, as well as one of the most important, which is ferric iron oxide, which is our blood. And so when you look at actual cellular life, the discovery of this stone led to understanding what was intended in nature for good water, what was intended in nature in terms of vital water, living water. And so if you go back to the aquifers, you go back to the volcanic systems, even if you go to Yellowstone today, all the stories that date late American history, early American history, up until the modern age, and even prior, and what made America one of those places everybody wanted to come in the world, because freedom came, but there was more to it than that, and it had to do with living water. And so the systems that actually operate, the purification of water in nature are all connected to the volcanic systems. For instance, in Detroit, you have a place called Mount Clemens, which is just north of Detroit. And it's no longer there as what it was and why people came to Detroit in that area in the first place. There were sulfate healing springs there, and people came from all over the world to get into the sulfate healing springs. We have ghost towns all over America where there used to be crowds of people coming from all over the world and a huge economy because of the source of the water. Now those have all dried up. So this discovery that was made in the 50s, 60s, took the guy 20 years of traveling around the world. I mean, he didn't really make his true last bit, what we call the actual finished product or the raw material, the finished raw material, until he had been working on this trail for 20 some years after he was already working in that industry. And when he delivered it to us, he knew what he found. He was able to produce something called activated oxygen in water. What that means for you or me or anybody that's, understanding what you're working with, it's a additional OH negative that attaches to your water cluster. So you have water molecules, and then you have clusters of molecules. And so when you get H2O, it's obviously have 2 hydrogen and 1 oxygen. When you get H3O2, you get what's called structured water.
They call this fourth phase water.
Yeah, so he was the first person to emulate nature and make the ability. Now the difference, and I'll cover this because I think this is a very important thing to understand if you know, especially in the cannabis industry with dealing with water, is you can use a machine. And I look at water as like a mirror, and it doesn't hold the energy itself, though it can hold things that do hold energy. It lets energy pass through, but you cannot charge water itself. There has to be something charging the water. So in this case, you have mineral salts, just like the ocean. The ocean charges the water with salts. Without the salts, you wouldn't have all of that life. And the salts all come from the volcanic vents at the bottom of the ocean that produce salts night and day, 24/7. Those salts percolate through the system and go through the system from bottom up. And as you get to different depths of the ocean, you have different concentrations of mineral salts based on whatever reactions are taking place from these types of elements. And so Shimonishi discovered these things and then brought that understanding to us and said, this is the way God intended us to drink water. Now, what comes from that? All fish, all living things that live in freshwater life and even saltwater life, you can use this in saltwater life, benefit from that, because now we have the best state of water and the best ability for the. So what, like going back to this test, what you're seeing happen is that structure, that change in the environment, whether it's soil because the water's there, or in the plant or the human, will absorb that structure. Now a machine, because water's like the mirror, a machine, they'll tell you, well, you got to use the water right away, right? And the reason for that is because you didn't really charge the water. The water loses it right away. It's that you didn't charge the water. You ran water through a charge, and the water responded to that charge. And then as time went on quickly, it broke down the formation which the charge made it hold while it passed through. Whereas the minerals, with the minerals, let me just say this, whereas the minerals, where they absorb into the water, they dissolve and become a part, they hold that charge. And so now that charge is able to emulate for a long period of time. Without disturbance, longer. With disturbance, you can purify a hot tub for up to a year using these minerals. They can keep it for water fresh.
So you have to keep it sealed, I guess, for this charge to maintain in there?
No, not with the minerals. It'll just not be as long. It will just not be as long because you're introducing it to environmental factors. So once you introduce water, this is the trick on water. So like say distilled or reverse osmosis. Unless you have a completely sterile situation where the water can be sealed immediately and never open to any environment, it will not stay clean. It will not stay fresh. In fact, as water's coming out of these systems, these RO systems, on the other side, there's all kinds of crap building because there's nothing there to kill it. So in your lines and your stuff, it's easier to get funguses and molds and bacteria on the other side where you're actually not putting any chlorine or anything that would actually kill what can grow in there. And that's the hard thing about water, is understanding what really is keeping, like fresh water systems. It's the positive ORP. Where does that come from? It comes from the springs and the streams, and the acid that comes from rain, the acid that comes from your leaves. The average rainfall is a 5.5 pH in America. And that's normal. That's not like, oh, it's acid rain. We're not all dissolving. You don't see, people's cars just getting rain acid, like as if it's some sort of destructive thing. Though you've heard acid rain, it's kind of like a dumb way of saying it because rain has always been in an acid state. Alkaline rain would actually be the worst. Imagine if you started getting rain that was like 8 pH. Plants can't thrive in that. We'd be a desert real fast.
So you had a question real quick, Tyler?
No, I did not have a question there. I was actually curious myself about the RO water. I'm glad he touched on that there. I don't have to.
Well, I just want to touch on water in general that has different states. Your different state of waters that you make sure you cover the bases of what is water in general. And that's why they add chlorine to your water, because the freshness is gone. And distilled and RO are dead water. There's no freshness whatsoever in them. So anything harmful can just take over.
Well, and
in fresh water, you have a resistance to environmental factors.
Real fast, just what we're talking about, right? We're talking about scientists trying to replace the fungi and bacteria. Well, you also have a third layer, and that's with engineers and scientists trying to make clean water, right? They're trying to engineer that process. When you can't make clean water, you have to allow nature to go through a process to turn it into a living state. And then real fast, and I'll give it back to Matt, is when water is when you clean it with an RO system or distilled water, it becomes a vacuum, right? So it pulls everything in immediately. That's why it's so sensitive to pH. That's why you only have to agitate it and it drops its pH super quick. But it's because it's capable of releasing gases, but it's a vacuum, right? So it's looking for balance in some level. And what we're discussing here is really engineers and scientists trying to solve problems or trying to make things easier. But through that process of doing it a lazy way, it started to create a long-term 100-year problem.
Yeah,
Matt, go ahead.
So going back to the creation of this, it starts with black mica. And okay, so on the surface of the Earth, you have four main components that are the majority of what you have here on the surface. And it's oxygen, silica, iron, or aluminum and iron. It actually goes aluminum third and then iron. So when you're talking about the layers of the Earth and the surface being what are the components on the surface, it's in that order. And so mica has that same exact order, especially the lava, the magma, and that would make sense, right? So magma created the layers of the surface of the Earth. It's very primordial, and it's the most it's the absolute definition of the word primordial, because there's nothing more primitive than a volcano, and there's nothing more primordial than creating the surface of the Earth that we all are a part of. Now, mica, and there's documentation that NSF and research professors have been paid to produce science showing the data of mica itself. And some of the most important data that comes from mica is its structure and its contents. So the structure of mica is called lamellae. And what that means is it's like an intricate woven sheets like mother pearl or human bones or animal bones are made in that same structure. And then the contents, you have basically potassium ions spacing these sheets in mica, much like our cells and plants and animals space their cells with potassium ions. And then you have the ferric iron, which represents like our blood, right? And you have the space chargings, the distance of these charges, which are identical to the human RNA. So you have a connection between the stone and all living things. And of course, science has already shown that, and that's where they changed from evolution to volcanic soup theory, it's called. Whereas I look at it as more like material used to conduct life or make life. It's, I guess, different perspectives on the data. And so, because the data is the data, and your opinion on the data can vary from person to person, or how you look at the data, I guess, could be your own personal view. But the data is the data.
So let's dive into the consequences to this. So like, before we get too much into the science and kind of overwhelm people on it, because we can go. Matt Edgardi and I have been talking about this for 15 years. So just keep it on a very simple level, right? Let's just look at what we've done with this Excel spreadsheet or this report, and we will dive into this right after. Is we turned this report into Can you see we turned the report into an Excel spreadsheet because we were able to pull measurable metrics off this 120 plant, $30,000 field study report over a course of 4.5 to 5 months. We're able to pull measurable data and turn it into an Excel spreadsheet. So, and what we found, just to bullet point it, is there was a 50% increase in cannabinoids. There was a 75% increase in terpenes. There was a 20% increase in terpene profile. So what that means is there was 16 cannabinoids in the controlled group, and there were 20 cannabinoids in the treated group. There was a 5% increase in yield. There was an 85% reduction of powdery mildew and botrytis, which gives excellent evidence to prove that the bud rot and powdery mildew actually start in the soil. They don't start on the surface of the leaves. And then we were a near complete remediation of pesticides and fungicides. And the main one we tested against was Eagle 20. Have you guys ever heard of Eagle 20?
Yeah, it's that I forget the chemical name of it, but it's
a lot more
you,
prevalent than people think. You know, everybody's like, "Oh, don't need to be using it." But I see it in almost any large size garden I go to, especially on the more illicit market areas. You know, it's no surprise anymore when I hear about it. I hate it. I don't like that it's being used. That and Avid, you know, when used inappropriately. It's
what's the chemical name of that?
Easy ways to get around
it. What did you say?
Troy, what was the chemical name of that? Because Eagle 20 is just the brand, I guess. What is the chemical name that other people use?
The chemical name of that specifically, and everyone knows it's Eagle 20, is
isn't it the microbutanol?
Microbutanol. Thank you. Appreciate that, Matt.
That's it.
And just so you understand the consequences of that, in Colorado 6 years ago, they recalled $10 million of edibles off the market because it spiked in Eagle 20. So in all industries, first comes experimentation, then comes litigation, and then comes regulation, right? So we're passing the experimental phase and we're starting to shift into the litigation phase on various aspects within the industry as it becomes more legitimate. After this litigation phase of saying, hey, that's poisoning people. Hey, that's getting people sick. Hey, you shouldn't be doing that. That's illegal. You shouldn't be having exposed wire. Then the industry goes into mandates and the regulatory process, which we're starting to shift into. So just to kind of loop this back over to because I don't want to dive too much into the consequences of pesticides and fungicides because, well, real quick, for example, I think actually the monster that's been caused in the cannabis industry is for big ag in general and food is our awareness to what is being put on our plants, right? I don't think that people really put too much thought into that. Even the farmers really put too much thought into that in the last 100 years. But I think cannabis is going to bring this to the surface, and people are going to start at some point look for healthier food. And we're hoping that Drops of Balance ends up becoming the solution to big ag on remediating these pesticides, fungicides prior to harvesting the food. And that's ultimately was the goal of this test. Although all these other results, all this other measurable data came from this, which we had a hypothesis, but we didn't really realize how much these chemicals actually affected our plants and in general fertilizers, because 99.99% of all fertilizers that are liquid that are sold to us, they're not just selling extra chemistry to us, but they're also they're latent with heavy metals. So that's why a lot of people, we think we have to toss our soil because there's extra salts in there. That's not the case, actually, a little bit. But what's actually happened is all the heavy metals that were left behind with the fertilizer bottles we used. So and it's almost impossible for me because we're a small, tiny company. For us to save $30,000 and do a test, that was huge for us. It took us a year and a half to save that type of money. For these multi-billion-dollar corporations, they have to be aware in some level that they are leaving behind heavy metals in our soil, which ends up affecting our EC and our soil biology in general. And in the report, there's actually links to other studies referencing other studies of the consequences of heavy metals in crops. But let's just turn this data point real fast into this crop. So, for example, this grow, they were given a gallon of water a day. The growing season was 150 days. The cost of the minerals for 25,000 gallons of water, to clean water, it costs $1,500. So it costs in this level 6 cents a gallon to treat. The controlled group lost two-thirds of their crop to mold. So we have right here we put 60% in because that's what they lost. The crop was 120 plants. The average yield was 4 ounces. The controlled study had 12% THC, and that's going to be an interesting factor later. And then 70% of the crop was sold to the market to flour. 30% went to oil, and they had a 1% terpene percentage. With our treatment group, so a couple other factors is each pound was sold for $450, and the gram of oil was sold for $7 a gram and wholesale level. So when you compare these factors on the before and after, they brought in this crop $5,253 in profit because 2/3 of their crop went to mold. If the entire crop, let's say, for example, now we're using a hypothesis, if the entire crop was on the regimen of the minerals, the value of this crop would have been closer to $14,633. And the difference is that in the treatment groups, the ones that were being given the minerals, only 10% of the crop went to mold. And this test was done in Oklahoma in greenhouses in the peak season. So that's why there was such a big, huge mold factor. And again, we were looking for remediation of pesticides, fungicides, all these other things growing in this horrible environment actually ended up being a benefit to us because we started to identify more of what actually was happening.
Interesting.
So you guys want to go through the report real fast? I can bring up some interesting details to the report that I think a lot of people would be scratching their head.
Definitely.
Absolutely.
Definitely.
Okay.
Sounds like an interesting product anyways. I'm excited to check it out.
And everyone's going to have access to the report. And I'm very grateful that you guys are bearing with us to explain this information because this is our first time. This came out 2 months ago, right? This is our first time explaining it. So it's going to be long-winded the first time we ever explain anything.
We're a bunch of nerds, man. We like this stuff.
Yeah, before we dive into the report, do you just want to give, like, especially for people that are just kind of tuning in, just give a really quick breakdown of what exactly the drops of balance is, and who's it kind of targeting as well. You know, I think that would be a good start for people. And then we can dive into the meat and potatoes of it. I think that'd be great.
Since we can die in 4 days without drinking water, I am literally talking to everyone that drinks water. It's like, I'm not trying to be global. I'm saying literally our water is everything. I mean, if you go into politics, the Bushes, I think it was, bought half of the Brazilian rainforest, if I remember straight, 20 years ago, trying to control the water. Our ability to clean our own water and bring life into our own bodies and plants it is the frontier we have to overcome. And then, so did he ask the second part to that question was
who it's targeting and what it is basically?
Oh, so what is, and I'm going to let Matt answer this one, but how I like to break it down and keep it simple, we basically take sulfuric acid and we dissolve black mica into sulfuric acid, and so we turn a rock back into a water soluble form. And because the black mica is so basic, we found the most purest form of the black mica. It breaks down to the most simplest minerals, and even the scientists after 60 years still call this a phenomenon, that once you introduce the minerals into the water, they begin to keep fractionating to smaller and smaller trace minerals, and it is why they think there's close to 100 plus ionic sulfate trace minerals in the concentrated form of the, or in the drops balance after you clean the water. And yeah, so it's dissolved rock that turns into a salt. And then Matt, though, Matt really gives the scientific.
Yeah. So in nature, obviously, we discussed about the volcanic eruptions, and that's what volcanoes use. Volcanoes use sulfur to create the sulfuric acid producing sulfates, which are your water purifying, or is your water purifying system in nature, your freshwater purifying system. These sulfates get introduced, whether it's ocean water, fresh water, to the system, and they are formed with oxides. So when you look at mica, the content, the mineral group are known as oxides, which means all the mineral ions have additional oxygen molecules, like ferric iron oxide, Fe2O3, or whatever other mineral that has come in the complex from the mica itself. And that's an important thing to understand. This is not an isolate. This is not something that was like, well, we designed this special formula. No, it's the complex that's extracted in its sulfate form from black mica as it is. So as a volcano would do, or as you would get from any healing hot spring, for instance, if you just do deep diving on healing hot springs, they're all sulfur based, they're all sulfate based, and they have the same complex, the same ratios, not identical, but similar, because the ratio doesn't have to be identical, nor will it be identical based on rock formation. But there will be a very close similarity. Plus, testing has all kinds of room for error when you're testing for minerals and ppm and ppb, parts per billion. But in this case, so you have a holistic extracted sulfate solution, which was what we call primordial or primitive elements. So they're unadulterated, so to speak, as pure as you can get them in the form they would come from, say, these systems. And so when you add them to water, they actually have, so let's start back with mica, just so that it helps you really understand what this is. In farming, in agriculture, you have what's known as vermiculite. And vermiculite is a form of mica that's had its moisture released by heating up that stone to 2,400 degrees. People add it back to their soils in organic farming, all kinds of farming, to hold water, to add trace elements. It has silica in it, but its main capacity is to hold tons more water than its weight. So it has the ability to keep your soils that need to hold water, extra ability to hold water. So in a sense of worldwide industry, it's used for almost everything. I mean, it's used to absorb the chemical effects of gasoline. It's used for chemical spill cleanup on the sides of roads. It's used to insulate buildings for fire retardant because it's very fireproof. You can't dissolve mica. It'll just continue to be mica, but it might lose its moisture, which is what vermiculite is. And then from there, it's also used in the ISS, or, in the ionosphere for all their satellites. They have to use mica because it's the only thing that can withstand the radiation from the ionosphere. And then when you're talking about on Earth, it's obviously the main substance. Well, with this formation, you have two of the most important ingredients in life, and that's ferric iron and sulfur. And the reason why those are the two most important ingredients in life is because the biogenesis of a cell of plant or animal begins with ferric iron and sulfur fatty acids. And if you look that term up, I know sounds very scientific, but it's a very important thing to understand, especially when you're working with water, growing, and in general, just life being balanced in general. I think knowing those things gives you a better understanding of what you're working with. And to have a complex that gives you the ratio as nature would give it rather than some isolated form is where you really have the true potential, because there's an ion exchange process, an ability for flocculation, which you don't get from machines, or you don't get the true ionic exchange. Whereas what Mark might talk and explain is fractionating. It's more it's called ionic exchange, and that's when you have electrons and being rearranged.
So to just explain real fast why this is just so absolutely important, why this is such a big thing, right? So there's something called the law of minimum and the law of tolerance. That is not a theory; it's an actual law that was discovered over 100 years ago that we've been missing in agriculture and science, again, for the last 120 years. And so basically what happens is these minerals, they get the minerals in general are so tiny that we still haven't been able to develop the calibration or the machinery that has the sensitive calibration to identify them in water, right? So because we can't see them and because we can't identify them, we only focus on what we see, touch, and test, right? So we are throwing in all these macro minerals. But what they have discovered in the law of minimum specifically, it's not the macro minerals that unlock all of the available nutrients. It's actually the smallest trace mineral that unlocks all the nutrients. And I got to give you an example to this. So full spectrum crude oil versus an isolate, right? When you refine the crude oil all the way down to just THC, what happens? It goes from a viscous state to a powder state, or an isolate, or a crystal state, right? So wouldn't that same type of thought process or chemistry or science happen in all molecular levels, all the way from a small molecule all the way up to a rock or a mineral state, right? So same thing over here with trace minerals. If you want those trace minerals to be more viscous in your soil biology, you need to add the trace minerals. But the issue with the trace minerals is that they're so tiny that they literally fall through your humic layer. The only thing that's capable of capturing them is the fibrous hairs that the bacteria and the fungi create within the relationship to your plants. And when you introduce synthetic fertilizers, it makes the bacteria dormant. And then when you till your soils, and all tilling isn't bad, but when you till your soils excessively and disc it continuously without ever introducing soil biology back into it, there's no more fibrous hairs to catch the smaller trace minerals. So what's left behind, just through a density process, the law of densities, the larger trace minerals or the larger rocks are left behind, and the smaller stuff is washed down and goes back into our water municipal system or into our water tables and so on. That's the significance of that. So let's dive into the report if you guys are open to it, and show a few things around this.
For sure.
Okay. So when you go through the report, anyone that reads it, they're going to have an abstract where they're just going to talk a little bit about the overall what they identified in the report, then or the study. Then the second one's going to be the introduction, where they are talking about why is this important to agriculture in general, and what's going on. So then they're going to go down. You're going to see potting of the plants. They're going to explain the experiment. And what I like to do is they're going to talk about the curing, the sampling, the testing. So they're going to go through the entire procedure. Again, this report will be published on various scientific journals in the next few months. So at times when you look at these reports, they're not the most easiest to read initially for most people like us. But what you want to go down to is the results, because that's really the best where to start on this on for anyone, because that's really what we care about, is what's the actual results of this test. So you come down, observations, results, and discussions, and that's going to be starting at page 4. When you come all the way down there, where the first thing we're talking about is the pesticides and fungicides. So as you can see right here in this graph, tests were pulled, full lab reports were pulled every 2 to 3 weeks. So as you're coming through right here, powdery mildew and botrytis started to get identified in the crop, and because of that, they mixed up a full regimen of microbutanol, Eagle 20, and they sprayed it on all 3 treatment groups. So the blue line is the control group. That's where no drops of balance was used whatsoever. The orange line is a treatment group with the drops of balance, but they were the soil was given 5 mLs per gallon one time prior to planting, and then they were given 1 ml per gallon the entire time, whether it was watering or fertilizing. 1 ml per gallon was always introduced to the water, and then they were a foliar spray of 4 mLs per gallon was given once a week. And so the gray line is the treatment group that was not given 5 mLs per gallon one time, but it was given the drip and the foliar with drops of balance. So as you could see, there was almost let's say a 95% reduction in powder in Eagle 20 4 to 5 days after spraying it, an almost complete remediation of this pesticide or fungicide off the crop. And still at only 1 ml per gallon. So for drinking water, you're using drops of balance for drinking water at 5 mLs per gallon. But for roots, you want to reduce it to 1 ml per gallon because roots are a lot more sensitive. Still, though, at 1 ml per gallon over a course of a few days, it's capable of breaking down this molecule that normally that can be detected for months, if not even a year or so after it's been sprayed, because it just sticks around. Do you guys have any questions on this one part?
Well, I'm kind of curious. So you're saying that the microbutanol is basically disassembled easier, and then now it's not really a harmful product in your soil anymore.
Exactly. So what ends up happening actually is it's insane. All that most people don't realize that they're buy food from Target or Walmart or Safeway. They're walking around with an average of 54 pesticides and fungicides in their body. If you go buy it from the cleanest source, like natural grocers, they're walking around with about 24 to 25 pesticides and fungicides. The average human being. Okay, this is insane. That fixes that problem. Yeah, so that's what that happens. That's what our primary focus was. Right when we saw this, we were just like, okay, awesome.
Yeah, chemistry is cool. I like it.
And just so a little bit funner fact too is that initially because I know a few people are probably wondering how fast does it start to disassemble the molecule. In the first 4 to 6 hours, it actually makes this molecule more effective when using it, because just like Matt said, you put the water into honeycomb clusters, so there's more surface area. So this pesticide actually becomes, or fungicide actually becomes, more effective in the first 4 to 6 hours of using it. After that, the molecule begins to get broken down and destroyed. So this is also just another graph representing the microbutanol of the Eagle 20 as you're reading through. This is where now it starts to get very interesting. Okay. Yeah. So we're all concerned about increasing our THC factor, right? For most industries, we're all starting to shift into a higher terpene profile as well. But so on this test, and explaining once again, the blue is the controlled, and the orange is the treatment group with the soil. The gray is without the soil. What we found is the treatment group that had a 5 mLs per gallon one time had the best results. So it was the final, and when you scroll down to the very, very bottom, you can actually see all the lab reports, and it's a hyperlink to all of them. But we saw close to a little above 19% THC or full cannabinoids on this plant on the treatment group. The controlled group had a little under 12%, and then the treatment group without the soil had the lowest. And this is where I wanted to explain some interesting factors here. We all talk about when you stress the plant out, it's supposed to produce more cannabinoids, right? And this is proof. This is proof that when you stress the plant out, it increases the cannabinoids, because the controlled group, 2/3 of the crop had powdery mildew and bud rot. So the whole time that crop was stressing out. So, and as you can see right here, the controlled group was underperforming up until it went to flowering, and then it spiked up. And this is my hypothesis. This is my guess. And Harley Smith is actually reviewing this report right now, and he'll be giving us his feedback soon. So you can see that the THC is actually increasing. We think because the plant is stressed out. What's interesting, though, is that what we can see is we can see a rate of how much more cannabinoids are being produced the entire time the plant is stressed out. So a lot of people that are saying, oh, you should stress the plant out in the last couple of days of flowering. Well, how much of that is actually benefiting you in general? Like how much it is benefiting you, you could see that, but how much is it compared to how much yield you're losing, right? In the time they're actually starting to that stress.
Yeah,
does that make sense?
We're growing trichomes. We're not growing biomass, so it would definitely make sense to me.
Yeah, it's a way of identity. It's a way of honing in your systems and processes within harvesting this crop or crops that have essential oils to what you want in general.
Yeah, some of the best flour I've had actually had pest pressure on it, so definitely makes sense.
The controlled the treatment group, the one that had the lowest, which is what I want to talk about for a second, is it had the lowest. So it was the least stressed out crop. It was a lot less stressed out, so it wasn't producing as much cannabinoids. The difference, though, in a commercial grow, though, is that when you talk about oil production, even at 1 ml per gallon, there was more harvestable biomass that was capable of being extracted, which creates a larger return on investment because there's more harvestable crop in general, whether it goes from flower or to extraction. Of course, we know CO2 remediates some of the mold, yada yada. But I'm just making the point to this is that, yeah, even at 1 ml per gallon, this also shows that the plant, how it really is concerned about survival first, right? It's going to put these minerals to neutralizing the enzymes in the soil so that powdery mildew and botrytis don't get started. That's my hypothesis. And it's concerned about all these other things. But just like how Matt said, the water is going to stay clean until outside environments are introduced back into the water that uses up the minerals, right? So if the bacteria and these other pesticides and fungicides and toxins are using up the minerals, then it makes sense that it doesn't have enough minerals to reach its higher state of consciousness.
Definitely. Yeah, you got one food source.
Hey, are you able to hear me, Mark?
Is that Gardy?
Yeah, Gardy.
All right.
Yes, we're in, Gardy.
Yeah,
Awesome,
introduce yourself, brother.
About time. Sorry about that. Had to deal with some children getting back from school early for some reason. I didn't know about that today, so I apologize about that. It's good to be here with you guys.
Welcome.
You know, I think the basis of this whole thing is, I mean, we can get as scientific in chemistry and physiology as we want, but we're giving the plants and animals the smallest tools that the engine needs for the rest of the engine to follow along. And without those smallest tools that are the cellular level, if they don't get what they need, it's very, very hard for the rest of that plant or engine or body to follow along. And so we're just mimicking nature. What's supposed to be in our water, our soil, our vegetation, it's no longer there because what we've done to destroy our precious earth through, you know, the industrial age and so on and so forth, and stripping a lot of the layers of the earth away that we need for proper purification for our aquifers and so on and so forth. We're getting the plants what they need on the smallest level so that the rest can follow along. And what I've noticed with growing not just marijuana, but all kinds of things is it makes the fruits, the harvest, everything taste better, look better, it grows better. It's just allowing everything to function properly from the get-go. And I heard Matt talking earlier about, you know, why are you guys talking about the water? Well, the water is the key. The minerals in the water are the delivery method to allow all the good to go into the plant, but they're also the garbage collectors. So minerals have two main functions for all living organisms. That's catalytic and enzymatic. Catalyst to draw nutrients into the cell. They're also the garbage collector to take the garbage or the chemicals out of the cell. It's physiologically impossible to remove the garbage, the toxins out of the cells without the proper minerals in their proper state, their proper form, and their proper matrix, which Matt covered a little bit. So even for us, we should be drinking this water because, like you said, we have, we go to the grocery store, we have 40 chemicals that we don't even know about, probably 10 times more than that at this point. But it allows you to get the abominations out in the deepest sense out of living organisms and allows them to be in a homeostatic position to fully get what they need to function and to grow properly. Make sense?
I think I get what you're laying down here. So like the microbiology are taking care of most of the enzymatic bonds, and then you need the minerals to do like the ionic and cationic kind of exchanges.
So yeah, minerals are there for enzymatic functions though. The minerals act as the male, the enzymes are the female. Without the proper male, females allowing to be selective to our host, unfortunately for us guys, need the proper female proper male or mineral to be activated, right?
Yeah. Okay. You need that diversity. You need a lot of that.
Yeah. So if we're giving our plants 3 minerals or 10 minerals or minerals that aren't in these proper state, the proper form, the proper matrix, it's not going to get the full benefits of what it could with these minerals here. That again, they're not us. This is nature. We're just mimicking nature.
Yeah.
Using volcanic technology is what we call it. So like Matt had talked about the tree on the rock, you know, how it was able to thrive and look so healthy without any soil.
In the middle of salt water, by the way, just to kind of point that out, was one of the things he was interested in. How is it doing it in salt water in the middle of the ocean?
Right. So yeah, I mean that's the concept behind it, you know, and it allows us to, in product wise, to be able to get the cleanest, you know, the most yield, the most bang for our buck when we're dealing with growing. I don't care if it's tomatoes, pot, whatever, you know what I mean? You're going to get the most bang for your buck. And I've seen it through and through again. It's awesome now that we have this data that he's collected and these tests that he's done that we can share with people. You know, we've known over time that, well, it takes lead and arsenic and mercury and all these things out of our water. Well, it does the same for us, it does the same for plants. It just, you know, you have to give them this water consistently, you know.
And I just want to reiterate on the whole taking out of the water. Really what you're having is, and the guy that performed the test for Mark pointed out even, is you have a soluble and an insoluble state. And so like ionic, the term ionic is truly charged. So salts that are ionic which is an example, a great example of an ionic mineral is a salt. It means it's truly charged. It's been dissolved with hydrogen. Electricity is positive hydrogen. So acid is electricity. It's electrolytic. So when you get burned by acid, you're not getting burned by the heat of the acid because it's at room temperature. You're getting burned by the electricity, the excitement of the oxygen molecules from the power of the positive hydrogen that you're getting burned by. And when you harness that charge into a mineral ion, it's called ionizing or ionized. And that means the mineral now holds the charge, much like a battery. You have to have elements there to hold the charge. The acid itself is just like a free radical. It can, hydrogen by itself will boil water. But if you put it in, charge it onto a mineral in the right form, the minerals become life-giving. They become life rearranging to a bioavailable state, a state where you have nutrients in and toxins out, as Gardy described, but also and this is where the phenomenon, so at some point in science, we reach a place called an anomaly or phenomenon where there's no scientific explanation, but yet we see it take place. And that's important to know, because if you don't understand that side of science, then you can easily miss out on the most important parts of life, like planting a seed and watching it grow. And I also want to point out the term synthetic versus natural. It's all natural, everything. What you have is a difference of harmful byproducts versus non-harmful byproducts, because everything you do is synthesized by man. Even when you plant your flowers or whatever, you're putting it in a pot. Is that natural? No, you're synthesizing it. Even if you sow the field, did the seed fall on its own and get water on its own? And no, you synthesize that process. So I just want to point out how silly sometimes synthesized is looked at. Now, if you're talking about, is it an ionic solution of an isolate, like meaning one type of mineral, or is it a complex? Now we're talking two different things, but the same type of mineral, ionic. And by the way, colloids, for those that don't understand and know, are not dissolved. They're not a part of the water. They're actually very small particles that are suspended in the water, like colloidal silver would be a good example. Those are not ionic. Those are not charged. So they cannot just go in. In fact, they're too large to accept inside your cells. Yep. Now, let me just say this. They have produced colloids, and I'm sure many of you have probably heard of them, or maybe you haven't, but fullerenes, or these soccer ball carbon molecules that are what they call angstrom size, which can bypass the cell membrane. They have produced these or find these in nature, but those are the ones that don't exist everywhere. They either have to make it or they find it in like a specific something that fell from the sky in Russia. It's a different substance.
So that would be your state of minerals, right? You have your proper form, your proper state, and your proper matrix. Your form of minerals, well, what form? These are sulfate minerals. These are meant for freshwater creatures. Your state is the ionic versus the colloidal. It's like putting a handful of sand in your mouth rather than a handful of salt and waiting for it to dissolve. And then the matrix, minerals have complementing minerals that work within our bot physiology, plants physiology. If you don't have complementing minerals to complement the other mineral, it's not going to work properly and function properly in that plant. So again, these are the minerals that are supposed to be in our water, our soil, and our vegetation, but are no longer present.
So let's bring this back. Why this is so important. Right. So I brought a simple XY axis on the screen. Can you guys see that?
Nope.
Here, let me share my screen one more time. Present, share screen, XY axis, share. Can you see my screen? See my screen now?
Ooh, yeah, it's coming up.
There.
Okay, so just like how Gardy said, you have the male and the female, right? So you have the bacteria as the male, and you have the female as the minerals. Let's say, for example, and what ends up
it's actually the other way around, by the way. Enzyme receptors, the female, and the minerals considered the male. Just to make sure it's how you understand it, but that's what the understanding is.
No, thank you, Matt. I appreciate that. I want sometimes I use it as a general topic, but I like being actually very specific. So I really do appreciate that. So in this XY axis, there's something called an exponential curve, right? So this XY axis, if you have, let's say, one mineral and you have one bacteria, this bacteria is going to produce one enzyme, because there's only one mineral in that environment. If you have two bacteria and you have two minerals, you're going to end up producing four enzymes, because each of the bacterias are capable of producing different types of enzymes based upon the two minerals that are in the environment. So Drops of Balance has, we believe at this point, because again, science is catching up to the product, 100 plus ionic sulfated trace minerals. So you have all the minerals on one side, and then when you have a healthy set of bacteria on this side, there's other product I like called BAM. It has 84 plus bacteria. So when you have the bacteria and the minerals set up, you now have an exponential curve on enzymatic production. And if you want to max it out on anything, you got to, for soil biology, anything, you have to have enzymes. Enzymes is everything, right? So I wanted to point that out, and then I also wanted to go back to the report. Do you guys have any questions on any of that?
No, it sounds pretty straightforward.
Okay,
definitely interesting there. Deliver them together, and
well, if you also picture, if you guys have ever seen like speaker connections, like the male and female side of a connection to electricity, just look at as the enzyme receptor as the female end, and then the male end would be the minerals. And that's a great way to see, well, how do things get activated?
You know, it's funny, not to go off onto a different subject, but I was in a dispensary last week, and I asked the bud tender, I said, well, they had 3 different tiers. Mark, I was telling you about this last week, 3 different tiers of what you could buy, you know, like the low stuff, the mid stuff, and then the exotic, the high premium stuff, you know. And I said, well, these all have the same THC content, CBD. They all look good. They all smell good. I said, what makes them exotic or this? She's like, well, really just how it smokes. You know, we want to make sure it has a white smoke and it smokes really good. And looking back at all the times we've used this for smoke, it always has ended up with an end product that not only is like tastes clean and tastes awesome, but it literally, instead of even a white ash, it just evaporates when you smoke it. There's nothing left over, and there's no harshness at all. I mean, it's incredible. So the proof is really in the pudding. You know, we can sit here all day and give you the science, which we love to do, but the end product, and you taste it and you feel it and you experience it, even for yourselves, for drinking water, you know, there's nothing like it.
We actually had a question.
I thought it was interesting. So
yeah, we had a question from chat. Actually, there was a gentleman who wanted to know if the water could be beneficial for someone with colitis or Crohn's.
We can't give like health advice. Like that's not our job. We're not doctors, and that shouldn't, like, we don't mean to be like off-putting about that. What we would like to say is that, you know, good water in general is a great way to maintain health. So it can't hurt, you know, and that's the better way to try it for yourself. And, you know, that's all I can say, you know, in terms of try it for yourself. If it helps, it helps. If not, then I'm sorry, you have to suffer from colitis or whatever it is you're suffering from. But in the end, we can't, you know, that road's a road where it's on the individual's own pursuit of health and their doctor, right?
Yeah,
the only thing I'll say on that is, and this just goes for minerals in general, is that minerals are the male, you know, to activate enzymatic processes. And so if there's a lack of enzymatic processes somewhere and you get the proper minerals, it can start to activate things in all life. So
there's
that's
a lot of
basic physiology, though. So I'm not like giving you any.
There's a lot of things there's a lot of conclusions you as a seeker is going to have to draw, right? We're in the water industry, and claims make are big no-nos, right? And if we want to stay in the water industry and be able to provide a very inexpensive solution to problems, because we can share these solutions because we have this data, we have to stay in the water industry.
Now, if you're in Canada, you know, we have a natural health product license on the raw material for the ability to generate healthy cells, maintain healthy cellular life, and also treat anemia. So I'm sure that, you know, just in general, maintaining healthy cells is going to help support your health in one way or another. And you may get great results, you may not. And I don't want, you know, in the end, it's just knowing that in general, water is like the main thing you go to. I don't care when you're dealing with plants. If you got a major soil problem, you can flush with water and then start again with better nutrition. It's the same thing for all living things. So use that to your discretion. And I would definitely say that making sure you're getting a good water is going to be your optimal chance for bringing yourself back. If you're doing nutrition, or even if you are doing medicines from the doctor, you should still, water should always be a main factor in health.
Yeah, and there's a lot of other types of reports that we have developed over the last 20 years in other industries on a private level we can share, so that you can examine, make more decisions for yourself.
Let's get back on another thing, but I'm just looking in the chats about rosin and the extracts. And so if you can imagine how clean this makes the end product, the flour, you know, just think about how clean those extracts will be, you know, and that's something that Mark can get into a little bit more later.
But also because, Mark, your point of, I think your main point you've made about the amount of product that can be harvested because it's clean, and also because there's more product to harvest. I don't care if you're an at-home grower or you're someone that's doing a large grow. It doesn't matter. In the end, that's the end result we all want. I'm pretty sure. I mean, I'm pretty sure everybody's gotten to that point now, is you're seeking the purest and the best, not something dirty or something weak. And I think that's where the main story is told here. How can we get that? How can we achieve that? And Mark's information is really pointing that out.
There's another thing too, is Matt brought this up in a great conversation a couple months ago, is that they've also identified that because these plants, we've always known that these plants are bioaccumulators, right? So they've identified that they actually store the heavy metals in the trichomes, right? So when you don't have that white burn, it's when you have that white burn, it's because you're not smoking heavy metals, right? And that's also a big thing. So all the extractors, you're going to be providing cleaner product to the industry because the heavy metals never get accumulated.
The industry will basically be able to take all their products that have those 3 tiers and go right to the exotic. And that, I mean, that's just because of the way it smokes, and that's the way it is. And so looking at yield, looking at all these different things, their profits will increase, you know. Yeah, it's just overall,
we'll create new standards in the industry. Experimentation, litigation, regulation. If we, you know, people don't understand how in these concentrates, how fast these heavy metals accumulate in our body and then start to surface in various detoxing methods throughout our life. If they do get detox, and they could show up as cancer later in our life, but we don't ever connect it back to our love, which is the cannabis industry and the heavy metals in our food, in our medicine. So let's go back real fast over to the report, because this report also improves the systems and processes for people that are in the business of harvesting terpenes. Okay, so what we came to discover is that terpenes peak out at week 5 into flowering, at close to and this was like a weak strain. Like when you look at the controlled group, we're talking around 10% concentration of THC. Like, I'm excited to play with strains that are messing around with 28 and 34% THC. Like, what is the world record in THC concentration? That's what I'm wondering on biomass.
34 or 32 or something like that.
I don't know, but it's this gives us a new.
I think I saw like 43% or something.
I heard
Yeah,
that.
it's so
Oh.
skewed, you know. I mean, it depends on your moisture content.
Doesn't even sound possible.
Just-
Someone told me 9% terps too the other day. I don't know if that
Yeah.
was true.
Well,
Yeah.
if you have less THC, does that mean you have more room in the gland for terpenes, or is that irrelevant?
Okay, so this is what's interesting. All right, so when you look at this, the treated group with the 5 mLs per gallon one time, the terpenes peak out at week 5, and again, another great conversation we had a couple months ago between all three of us is we discussed that we learned that CBGA needs a coenzyme to produce the other cannabinoids. And so the coenzyme is a terpene, and I'll turn this over to Matt in a second. So the key is, and right here in the very, very beginning, when you go back to the very, very bottom and look at all of the reports from the very beginning, right from the get-go, the plants that were given 5 mLs per gallon. And I also want to try another experiment with 5 mLs in the beginning and then 5 mLs one time right when you go into flowering. But point is that right in the get-go, you're seeing a huge jump. Boom, instantly, like when we talk about enzymatic production and exponential curve on a day-by-day, minute-by-minute basis throughout the entire crop, these plants really start to take off. So right here, when the plants start to go into flowering, they max out at week 5, but then the plant really starts to cannibalize the terpenes after week 5 into flowering to produce more cannabinoids.
Cool.
So this is where people that decided they were in the business of harvesting terpenes and not cannabinoids, they should be harvesting week 5 or 6 into flowering, because that's when they max it out. Obviously, though, the difference though is that a lot of people would go for the biomass because there will be more of the to collect. But at the 5 ml rate, you see now the terpenes are jumping at week 5, so it's now creating different measurable result, which might encourage people to want to harvest earlier on to go for those terps because they're not concerned with the THC, which creates a new exotic level in the industry. And medicine in general. Each of these terpenes do different things for our bodies. So if you have more to harvest, then you have we were talking about supply-demand experience on reducing cost overall and being able to provide medicine to a larger mass of people. So yeah, let's turn that over. So Matt, real quick, can you and Gardy, can you guys remind me what terpene specifically does the CBG use to start to
it's actually a precursor to all that. They're called isoprenes, and they're the primitive form of all terpenes. So basically, once the plants produce an isoprene, then it converts over into some sort of terpene, which terpenes are used for all kinds of purpose. They're essentially metabolites, and the conversion process happens when the plant decides it needs this or that. And that's where deficiencies and other things, when the plant can't perform its function to produce what it wants, it'll take from other areas. And so when you have more isoprene capability, or let's say the plant's metabolism, and really the root of all things are what's the plant's ability to metabolize and what's there for it to metabolize. And so these terpenes are essentially used for immune system, immune function, cellular function, all kinds of things, warding pests, warding disease, just like you mainly incorporate it with smell and aroma, but the use for essential oils over time is based on the terpene content, the terpene profile, like lavender or pine or whatever it may be. They each have a function in nature in that plant to do something, but there's many more terpenes that are used for other things. So as the plant is going into its reproductive state, it's producing a high level of immune system, immune response, warding of pests. Well, of course, the plant's capability are going to be based on its ability to metabolize whatever you're feeding it and turn it into these precursor isoprenes that can then be turned into all these other different what you call terpenes or cannabinoids. In general, terpene is a cannabinoid, like THC is a cannabinoid. They're called metabolites. They're the end result of this process. And so what you're really focused on marijuana exclusively is that you have the highest level flavors, the highest level experience in terms of what it does to you. And each terpene, as those levels are higher, will give you an additional effect that the THC will not give you. And so when people say they like this type of weed or that type of weed or get specific feelings, you call it nighttime, daytime, it's because of the type of terpenes that are there and what kind of effect that terpene does. So the strength or the length, I should call it, of your high or the experience of your high is not based on THC content, but the THC with additional. Now, of course, it is to a degree, but in terms of the experience and the length, that will be more based on the terpene profile. That's why whenever you get high with a higher concentrated THC, it seems to fade faster than one that has really amazing smell and flavor. Those seem to kick in and last longer and do more for you than something has less smell, less flavor, but higher THC. And those terpenes and the profile are going to be only able to produce based on the metabolic function of the plant. And if the plant can metabolize and create these metabolites, whether it's in the heavy metal environment or not, is going to determine its terpene production and its cannabinoid production. CBG comes from that process, as well as CBGA going to THCA or CBDs from there. That's where the CBG will make the next conversion in terms of cannabinoids. And terpenes are terpenes produced in their state. Once they're produced, they're that terpene. They can be lost easy. When you boil cannabis, for instance, that's why you smell it go into the air almost immediately. Gas is off. There's ways to preserve them. People are freeze drying cannabis now to preserve those terpenes at 97% versus drying it in a room, which I don't know how much you lose. I haven't looked into all of that, but I know that it's much more from like just doing a traditional dry. But anyways, that's the I guess you could say the greater explanation of what function are we really affecting, and it's that conversion process, and that's to metabolize. It's also known as biostimulant. If you look up the definition of biostimulant, it's to make the plant's ability to absorb water, nutrition, and create a better environment for itself to have overall greater effects, overall benefit, positive benefits. That's what biostimulant means.
So I want to bring up a couple more things real fast, because I want this report to be torn apart. I want it to be examined. I want it to be questioned. I want it to be repeatable, right? That's the if we do not use the cannabis industry as the R&D facility for big ag, for our food, we're going to lose the real value to this cannabis industry, because this cannabis industry has produced a cheap and inexpensive and still accessible to the common person testing, so that we could identify the nutritional value of the food, of the medicine, so that we can take these systems and processes and transfer them over to big ag. That is ultimately what we need, because big ag doesn't have a research and facility anymore. They don't do a lot of testing anymore. The standard is the standard, right? So this is something as I really wanted to bring out to you guys, because I'm hoping to only validate what you guys feel as an end consumer around these things, especially when we smoke something and we get like an anxious feeling or like an uncomfortable high, right? We've all felt it. We blame it on the sativa, but what's really, I think, actually happening is that when the plant is being grown in a unhealthy or sick environment, or maybe the person is sick in some level, I think this test is going to show that different types of terpenes are being produced throughout the plant of whatever it's going through. So if it's healthier, it's going to produce a totally different set of terpenes than the plant that's totally unhealthy. So when you scroll all the way down, and again, these are things that need to be further tested with more testing, but hopefully pointing you guys in a direction to examine might bring more validity to this thought process of what we experience. So when we come right here and we click right here, these are all going to be hyperlinks, and you'll see I have the controlled group, the test 5 no DOB with soil, and test 5 with DOB of soil. So when you click on each of these, and I'm just going to do one at a time. I'm just going to show you this information so where you can search for it yourself. And you bring each of these tests up. You're going to scroll down to the terpenes, right? And this is what you're going to see. And just pay attention to the red one and the blue one, right? So this is the controlled group that had 2/3 of the crop had powdery mildew and was stressed out the entire process. And you'll see these. And you'll also see that they only had 16 terpenes. Right here, you come back. Come right here, click the next one. This one also only had 16 terpenes, right? The minerals were used up to help stop the botrytis and the powdery mildew. But you can see the difference in the red and the blue, right? Oh, yeah. And when you examine all these other ones, there's difference. And we've identified this is what controls the high. This is what controls our hypersensitivity to the ether when we smoke it, right? So if we have a different chain of molecules, it's going to create a different connection to the ether, to God in this moment, right? That's what we're discussing. Scroll all the way down. One more time. Click on this. Yes, we have turned growing into a religion over here. Yes, yeah. We have. Yeah.
Hey, Mark, there's a lot of questions in the comments section. Do you want me to give my number? Do you want to give them a way to contact us to get any questions answered? Or how is that going to work? How should we work?
What do you guys suggest?
Do you want to try to answer some of those questions now?
Yeah. Yeah, let's start. We're done at this point. Let's start going question by question.
Yeah, I've got
DP's pulling up some stuff there. He's got the text.
Yeah, I've got a couple right over here.
I got one while we're waiting. It has to do with molybdenum and maybe the law of tolerance and minimum. And I think if I can remember correctly, that molybdenum is made only with microbiology, or can it be made synthetically?
To my understanding, it could be made both. Yeah, kind of like what Matt said, synthetic means just man altered, right? So, and if I remember straight, a study came out a couple years ago when they added, I believe it was molybdenum, to Australia with wheat. They went from a wheat importer to wheat exporter in 1 year. Wow. Right, so each of these minerals do different functions within the plant, and that's the interesting thing is us discovering. Because, okay, so let's go back real fast and just to show you an example. They learned a few years ago, about 20 years ago, and it's not relatively. It's not information that gets released to the public too much, but they realized that a copper is heavily used up in the last 3 weeks into flowering, right? To bring or ripening. Let me rephrase, into ripening of fruit. And they've identified it to bring it as being one of the key things for flavor, right? So would it also make sense that possibly copper and these terpenes are being used up in these last 3 weeks, possibly to produce more cannabinoids? I don't know. I have no idea. I'm a hydroponic store owner. I'm not a fucking scientist. Okay, like what? Stop putting this fucking pressure on me to get these questions answered. Like we should be actually having scientists to do this actual work versus using a small business owner and the year and a half of profits to bring this information to the surface. I'm not mean to be like an ass in that, but I'm just saying I don't know. This is me reading, learning, and interpreting just as much as you guys. I am you.
You're doing good work, man. Like you've amazed the shit out of me. I'll tell you that.
We are you. Like all this information doesn't just come from me. A lot of it's coming from Gardy, from Matt, us sitting together, having mastermind groups over 15 years, just being like, what's happening here? You know?
All right, so we got Derek Frick, if he's still on. How can I chelate any heavy metals in my soil without locking up other minerals? I have looked into zeolites. Could this be a viable option to lower heavy metals? So he apparently wasn't on maybe in the beginning of the conversation. I don't know if he's still on now. Matt, do you want to tell him about zeolites, or would you like me to?
Well, I just wanted to say something quickly about zeolites or even diatomaceous earth, that you got to be careful when you introduce too much of that to your soil. You can mess with the conductivity. And so unlike the ionic minerals, the zeolites and those other alumina silicates that are in colloidal or solid form, they have that additional conductivity ability, and it's because the levels of aluminum that are there. Aluminum is a very conductive metal. So you just got to be careful when doing that, but it shouldn't lock up other additional minerals. But in a sense of having too much or too many minerals, definitely you can do that.
It's interesting that he brings up zeolite, because I work underground as a miner, and during the blasting process in some of the paste undercuts, we put the zeolite down on the ground to absorb some of the ammonia from the blast gases. I guess
that's like vermiculite. They use vermiculite for spills, chemical spills, to neutralize things. Same concept. Zeolites have already. I mentioned to Derek that these are the virgin zeolites. So zeolites have already gone through the volcanic process. They've already been spent and burnt up, and now they're deposits normally on the ocean floor that we're getting these rocks from. They're also in a colloidal state. Again, a colloidal state, what does that mean? It means it's suspended larger in molecular size. So it's like, again, the analogy of putting a handful of sand in your mouth and waiting for that sand to dissolve rather than a handful of salt. So of course, to get the mineral or to get metals out of a living organism, it's going to be much more beneficial to have ionic minerals in their proper state and form that a plant already can recognize and use and uptake and process, correct? So that's what I meant by the virgin zeolites. They've already virgin zeolites, meaning that they're getting the rock that has not gone through this volcanic process yet. That's kind of what we're doing to speed the process up that you would see in nature for our water, that you would see, in our aquifers, our the healing hot springs, so on and so forth. But this isn't all of our bodies of water. If our water, our soil, they didn't have these minerals, which we see our soil dying, we see our water dying, they can't live in a pristine living, state that life can thrive in, because these minerals are that important to that ecosystem.
Yeah, and just going back to the zeolite question, I would just say that, like Gardy said, he's talking about the zeolites are spent from the volcanic process that happens in the ocean, which is where the volcanic vents emit the sulfates into the ocean in the form of salt. He's, in a sense of locking anything out, it shouldn't. Like I said, I would like to go back to just saying that you got to be careful how much you add. So it's always about, like what Mark talks about, laws of minimum and laws of tolerance, whereas you can add too much. You can have it too electrolytic. Everybody knows ppms and EC, that grows. If you've grown long enough, what that means. And if you get too much conductivity, you can cause additional imbalances or cause the plant to fry itself, so to speak. So I just want to make sure.
Say PC too. Potential conductivity is also a factor.
There's new ones coming out. Everybody's trying. It's like light, you went from Lux to PFD to now PPFD, and now it just keeps evolving into the next what's the real you know, so, but in the end, you know, I would say you shouldn't have any lockups. You should be fine. Just make sure it's not too much conductivity going on in the soil if you're having problems.
And no, we want questions, so that's good. If you're never asking too many questions. That was part of the comments.
Gardy, can you read the questions as they surface?
Yeah. Yep. So another one asked about worms and their ability to get rid of heavy metals. I'm not real familiar with that. I'm sure you could do probably an online search and figure that out. But do you know anything about that, Mark? Do worms?
Yeah. So just to really break it down, what worms do, worms basically produce bacteria, right? So they're going through eating things, and as this going through their digestive system, it's producing bacteria. Those bacteria then go on to start to do their function. There is an overlay between bacteria and the function of what the minerals do, right? Because the minerals is a synthetic created product to solve a problem. The bacteria is there to do the whole function with the rocks, right? So what you end up having is you basically end up just having nature do these same functions, but the issue is nature is not capable of doing their functions because the bacteria is dormant, because we have a law of tolerance, a law of minimum issue. Does that make sense? So the bacteria is worms produce bacteria that then start the function of nature. The drops of balance is just a product that's created to solve an issue that's accumulated over time right now. Hopefully over time, when we get rid of these pesticides and these toxic things, and we clean up our soil and our environments, drops of balance will cease to exist as a need, because we have bacteria doing the function of what it's been meant to do the whole time.
Yeah, and I think it's also important to note that there's a difference between the bacterial and organic matter versus chemicals and heavy metals and things that are harmful to even worms. And there's definitely a difference between the two, not to be confused, because worms do their function, but worms also need a healthy environment or a specific environment of organic matter to do their function. Now, if the organic matter is having a hard time, and your soil biology is having a hard time, so are the worms going to have a hard time. And I think that's the idea here, is that it's about the total environment being able to function properly in unison together, having a harmony in the environment. And of course, there's different types of foods. So this is not to be confused with food for a plant or a supplement for the plant. It's about an environmental state that you want your soil / water / inputs to be in when you're using your nutrients. You could use synthetic or organic when using this product, is a good example. So it's not about any one particular setup. It's about giving you the optimal homeostasis and being able to dial in on your inputs, whether that be synthetic or organic, or your medium for that matter, whether you're going hydroponic or whether you're going soil hydroponic or cocoa hydro or living super soil. So that I know a lot of viewers are probably having all these questions about what they already do incorporate, or what they're working with and how will it work with that. And the idea is just to have that homeostasis from the start with your water environment, and that go, because when you use this product, it's used in water. And I know most synthetic nutrients are, so it's very similar in that respect. But you just follow the basics. And unless like if your soil's already healthy, you should get the results from the basics. But if you're dealing with complicated soil, it would be like, well, you probably should flush with some additional amount to make sure that soil isn't locked up. So if anything, you can look at this product as something to unlock the soil rather than will it lock my soil up?
Yeah.
And also to answer the worm question, but I just want to kind of bring it all together. It's all going to work together, and that's what it should do.
So this is going for just you're starting a clean slate for your water, right?
Yeah, your water is your base for all living things. It's the beginning of all living things. So when you're looking at humans, plants, or animals, you're looking at majority water, period. So your water is the most important factor. Outside of you breathing air, which is how you consume other fluids known as gases, which is your main fuel, is breathing oxygen, breathing air. But in terms of that, it's water. And after that, it's water, and then it's your food. So water becomes the basis of your ability to filter, to distribute, or to have the functions take place. And the better the environment the water is, the better the functions can take place.
So can you add this to dirty water?
It has the ability to flocculate. And what flocculation means is to precipitate solids or particles that are in water, organic matter. But it also has the ability to work on chemicals as well. So let's say you had like a sludge water or wastewater.
I got water. It's just fuck.
Well, let's just go with the worst water. Let's go with sewage water. Okay. You could hold the sewage water up to the sun and not be able to see through it, and add enough of these minerals where it would flocculate it and become crystal clear at a certain point, and everything would sink to the bottom. And then you can separate those particulates that have separated now. But and keep in mind
all the bad stuff that's in the water.
Yeah, everything is going through an ion exchange and a catalyzing process where you have agglutination, deposition, and flocculation, which is a process that these contaminants that are in solid or dissolved form become insoluble and rendered. And you see them turn to a fine powder at the bottom.
Basically, these minerals have the ability to purify any fresh water better than any man-made machine. Okay.
If you go
give it back, restore it back,
still have the availability of working with all the other compounds and molecules and everything else that we need to for our plants to be able to uptake.
Correct.
Yes.
Yeah. Let me give you guys Let me give you one example of what you're talking about, so that I can confirm with you what you're talking about. So, like, if anybody's ever seen the movie Erin Brockovich or heard of it, it's got Julia Roberts in it, and she plays a role of a real life person who's has their own accounts today on social media that still is championing poisonous water. And this water contained chromium-6, which is known as hexavalent chromium. When we tested our product on hexavalent chromium, it just disappeared. So the way you test minerals can be complex, because you can test for overall ions, meaning, like, for instance, chromium can be chromium-3, chromium-2, chromium-6, which tests how much electrons are connected to the chromium as a mineral. If you reduce it down to its
real fast, Matt, you can see my screen, right? Can you see my screen?
Yeah.
Okay, so Matt, what Matt's explaining, if you went to the safety and testing under drops of balance, right here, all these badges take you to different links. This is over $25,000 of water testing. So this is the chromium testing right here. Matt, go ahead and keep going. So the chromium testing,
so what we saw is chromium-6 disappeared, because we were only testing for the chromium-6 that was spiked in the water. But what we found was that chromium-3 increased. And all that was mostly left was chromium-3, which is the inert, or the less the natural state that you would find chromium for animals or plants in a bioavailable form. Whereas chromium-6 causes all kinds of harmful diseases and problems. You take a little tiny bit of that stuff. There was no chromium-6 to be found. It was non-detectable, but what it essentially did was it showed a conversion from chromium-6 to chromium-3. Now, even with sodium fluoride. So when you have sodium fluoride in water dissolved in, the chromium or the fluoride in this so the sodium separate, and you have a free-floating fluoride ion, which needs, in nature, you have calcium fluoride. So what happens is your body has to donate calcium for that fluoride to become complete. What we found with these minerals is that conversion took place ahead of time. So If the water had sodium fluoride and you treat it with our minerals, it now becomes calcium fluoride over that ion exchange process. So now we have a calcium fluoride that's inert. It's insoluble. It can't get into our cells. It can't harm us like we found that free-floating radicals fluoride does. So those types of exchanges take place when you're introducing this into the water that has those chemicals or those bonds that are in there. And I do want to say one thing, because I want to be accurate here. There's two types of bonds when we're talking about this type of chemistry that are on Earth. There's one which is the strongest bond known to man. It's ionic bond. So a salt is the strongest bond in chemistry. And how chemistry works is the strongest bond wins. So when you have their chemistry, you have what's called covalent bonds. And those are weaker bonds, but they're the second strongest. So when there's a boxing match, the ionic bonds win. And so if you just think about in terms of having a primal ionic solution, it goes to war with covalent bonds and things that are not superior to it. And it also, because it's in its complex form, meant for life, right? Because of that's how we're getting it in nature, replenishing the system. You know, I've ever wondered what is helping all of the rotten organic matter in water, in natural streams and rivers. What's helping that stay fresh? And it's the springs. Every spring leads to the ocean. Springs feed the rivers, rivers feed the lakes, lakes feed the next river down all the way to the ocean. And so you have this process percolating through the system in trace quantities, just like as we would do it here in a setting like this. You're giving trace amounts. You're taking drops of balance. You're diluting it down by 1,000 times at drinking water level and like 4,000, 3,000 with your program or whatever when you're giving it in line. Even more so when you're giving it in line to the water systems for the plants. So when you think about the dilution level, it's very much like that. Trace amounts that are very powerful in what they do and perform the same function that we would expect to happen in nature. And that's what I think is the most valuable thing here is understanding, well, we got to do it like nature, because everything that we've done has gone to crap. It might work temporarily or might have, I mean, even if you look at LED lighting, it's great, but it's nothing compared to the sun, right? So nothing compares to the sun, but you can't control the sun, and you can't really control if you live north of the hemisphere of like having that cold winter. You can't. There's certain things you can't do based on where you are located, based on your environments. And in this case, we're talking about resetting that environment and making sure these functions can take place without the interference of harmful elements and harmful covalent bonds and things that are causing disruptions in the total picture. So whether it's the worms, whether it's the rest of the biology, because it's not a one and done. You have water, and then you have nutrition, then you have environmental factors. You still want to control your parameters, but water seems to be the trickiest because that affects the soil directly, that affects the plant directly. And that's the one thing that you can control inputs on, where you can get results based on your inputs. And so I think that starting with a good water and having the ability to create these bonds and exchanges, that, that's where the real fruit is coming from, is from having that ability to always say, okay, my water is going to be good. Well, if something's not working, it must be either too much inputs or not enough inputs or other environmental factors. And that's really what makes this so amazing for the cannabis industry, is that's a big deal. I mean, especially when you're talking about purity of plants and the purity of result.
Next time you go to a hydroponic store, go contact a fertilizer company. I think some of the key questions you should ask is, when using your product, what is a estimated return on investment before and after using your product? Second, what is the scientific data proving the efficacy of what you say your specific product and your chemicals in your bottle actually do? Because over here with the Drops of Balance, they, as of this point, have spent close to $55,000 as of this point, proving the efficacy of what it does. And what it says it does is we clean water, and now with the plants, we can now say it increases the nutrient density of the product through terpene production, and these other things we've already mentioned throughout the program. So
yeah, this stuff sounds great, honestly. I mean, it sounds like it'd be used in if you're doing aquaponics and stuff like that, and you want to help clean up your water.
Actually, yeah, that's my model that I have for the future, is to have fish farming with whatever type of crops you're trying to grow. And one of the biggest complaints right now with fish farming is the stench. And one of the biggest uses
real quick,
is
Matt, I'm going to interrupt you real quick. This is a fish aquarium, a turtle tank that my son has. Last time it got a water change was 6 months ago.
Oh, wow.
Wow.
Okay, so
It's
I
crystal
keep all
clear.
some of the debris or stuff, but it takes all the nitrogen, all the ammonias out of it. It keeps
Wow.
it in a pure, pristine, crystal clear living state. And so that's a good representation, because that water should look brown and smell like ass right
Yeah.
now. It's fresh,
So
sweet
does
smelling.
it allow beneficials to thrive and stuff like that as well, or is
Absolutely.
it going, okay?
Yes.
Yeah, that's part of the microbiology. That's what you want. And that's one of the most important things it does in terms of allowing the soil to do its own thing. And that's where I think most of us come into trouble with cannabis for the first time, is when we've made the soil not palatable to the plant.
Now, what if people are running like lines? Can you run it as like a replacement for enzymes and stuff like that?
Well, we create our own, and our enzymes just need to be activated. So taking enzymes, it's like, well, we need the proper minerals to activate the enzymes that we already have that are naturally there for us, you know. So taking enzymes is, how is that activating your enzymatic responses? There's ionic channels, ionic receptors attached to each enzyme that need to be activated by a mineral, a spark, that electric charge, you know. You're not getting that by supplementing with enzymes, you know. So that would be my.
In other words, the ability to produce versus the ability that you're trying to give yourself, that enzyme versus your ability to produce it itself.
Right.
And remember that all these enzyme products that they're producing out there in the market is a specific enzyme, right? That's not how nature works. The enzymes are constantly evolving and changing based upon the sugars that are being re-released back into the soil on a daily basis, telling the soil what it needs to focus on its key survival needs for the day, and then if it has extra, to reach its higher state of consciousness, right? So all these products producing enzymes is you're actually hindering the growth of the plant, because you're providing an enzyme maybe what needed at veg, because they identified this one enzyme that could be really great at veg, but they because they want to keep selling you more enzymes, they're going to say, hey, use it all the way through, but it ends up being counterproductive. But there's no actual measurable results. So but the study they did was just for these 2-week period or something or whatever, you know. So
well, keep in mind also the material that you give plants, the food has enzymes. So, you know, part of the ability for the plant to break those down with the microbiology and everything is the exact reason why you're seeing these results in these tests, is because when you treated the soil with the proper water, the microbiology could now do its work and metabolize more of this material that's made available to the plant. And that's ultimately what it's about. Your plant's ability to metabolize food and to create its own metabolites that then can do the functions of the plant, whether that's immune response, whether that's as its own natural insecticide or pesticide, or whether it's
communicate to the soil biology.
Its defense towards mold, its defense towards all these other things come from these primitive capabilities of these metabolites and the conversions of. And I know that people add, like they extract from, like, say, alfalfa. That's a great one to get your enzymes from. There's particular enzymes and there's hormones in alfalfa. So a lot of people have this, like, oh, if you give your plant this alfalfa juice, you're going to, or this extract, you're going to have super growth or additional growth because the hormones there. I would always say it's better to feed the raw material and make that as a process of the plant's natural, but that's just me. I mean, and the water is really like where that, like we've gone back to, the efficiency and all the different reactions can take place is the quality. That's why rain, whenever you see rain, especially electrical storms, whenever you have an electrical storm outside, that means you have a high sulfur content in the air. Okay? That means there's going to be more sulfur in your rain. And so you're going to see these plants take off in an electrical storm, especially if it rains really good and you have a nice one, because that's the water you should be giving your plants. And that's really what's going on. And that electricity also triggers oxygen in the air, which makes it better for the plants as well. But anyways, I just wanted to point that out because a lot of people don't understand rain and the importance of rain. That's why whenever you see them say they have a drought, it's not that they're not feeding their plants water, it's that their plants are now getting well water. And so the well water can't compare to the rainwater. Doesn't matter how, if you keep the water the same amount of water on the ground, the rainwater will outcompete the well water. Unless you have magic well water that's really good and pristine like a spring, you're going to have worse results versus rain. And this is a very close assimilation because of the sulfates, where you're bringing the water back to that rainwater capability.
Any other questions?
I have some smart that I can bring up.
I got a quick comment, Jared, while he's doing that. But just like looking at the state of that fish tank and thinking about the mining industry, like we recycle our water and it gets full of all these different contaminants and oil and like all this blast shit, and then we pump it up and all these different stuff and put it into like a settling dam or like a tailings dam.
Right.
Like I'm just thinking this drops the balance. You know what I mean? Like this shit needs to go in every mine up here because that stuff eventually goes into our water systems and
industry, industrial.
Well, you bring up a good thing. It's like safe disposal, right? Once you are collecting all these things,
correct.
You're responsible about.
And we do use that for this. They use these minerals in all of Tokyo for all their wastewater management at one point before the big chlorine companies came in and took over. So definitely they use these minerals to help clean the waters at Chernobyl.
No shit, eh?
Yes, for sure. But they weren't dealing with salt water. You got Fukushima, now it's all salt water, so these minerals aren't going to have the same ability to purify because of the salts overtaking, there's too much chloride salt, which is another form of minerals. Chlorides, these are sulfates. Chloride minerals are meant for saltwater creatures, but that's what we see the most of,
I have a question over here from Benjamin I found. It says, are you guys able to see the screen?
Yes.
Okay, there we go.
Will you read that, Cardi?
I am wondering what is their opinions on igneous-based rock dusts and also on liquid products like sea crop, 80 ocean minerals. So I think I kind of just answered that one, but go ahead. Matt?
Oh, I mean, it's all about the medium you're using. If you need it, use it. If it works in your regimen and you have the beneficials with it and your experience has been good, use it. In terms of, like, I go back to your inputs. If it's, to me, it doesn't make a lot of sense to be grabbing stuff from one location, but it does at the same time because, certain technology or certain things are only available in certain places. But there's many ways to get to the same road and many, ways to mix your soils and your mediums up, and using some sort of dust or whatever, it's fine. I mean, as long as you know what you're doing with it and get the results and you're using it for the proper reasons. You can add too much. I mean, it's like anything. Too much is not good and too little is not enough. So you find your own, but I don't really have an opinion other than,
I do.
If it works for you. I don't.
I have an opinion on this one. Just to be real, opinions are like assholes. Everyone has one, right? So So
Maybe that's why I don't have one on it.
So you come down and the rock needs to be broken down to be water soluble, right? So the most important thing is, yes, of course, add in the rock dust, right? Because at some point, if you don't keep introducing toxic material, hopefully the bacteria and the rock start to do the relationship and make things water soluble. So yes, do that. The issue with rock dust is most of it's mined out of Utah, and that's been a nuclear dumping ground for 50 or 60 years. And if you actually go and look at these products and look at the mineral composition of these rock dusts, uranium is normally one of those
top minerals.
Yeah, top minerals in the rock dust. They don't market that, but they're selling you uranium, redistributing nuclear waste,
and they don't have to put it on there either because they
don't. Yeah. I've only seen one company out of however many out there that are doing this. And then the second thing also is just because also this also plays into the slightly with the rock dust, but also it's just because bacteria keep breaking things smaller and smaller down. But the thing is, with the law of because the law of density, we're not talking about a theory like gravity. We're talking about the law of density, right? So things sink because things are heavier. Huh? Just ignore it right now, honey. Because of the law of density, it's what you're having is the smaller trace minerals are sinking. So the sea salts, right? When they go in there, they harvest this water and they evaporate the waterway, and the minerals are left behind. That's missing the trace minerals because the trace minerals sink to the bottom of the ocean. They're not harvesting that water. They're harvesting the surface of the water. So that's my opinion around that. I just saying, if you're going to invest in a product, just law of minimum, law of tolerance, the smallest trace minerals will unlocks the rest, and you have a 3-month crop.
And I also want to address, one more thing about the question. Might not be answering the question, but it's related to the topic enough, and I feel it's something very important to understand. A lot of people get caught up in the terms organic and inorganic, and the simple meaning behind both of them from a science perspective is whether it contains carbon or not. So people think, oh, if I give this inorganic rock to the plant, it's going to turn it to salt, and then I'm going to take this plant and eat the plant and get my minerals from the plant. When in nature, that's not how minerals are replenished. Minerals are replenished through water, essentially. Through rain, look up the potassium cycle. So potassium dissolves into the rain certain times a year. It's called the potassium cycle. Very interesting stuff when you start getting into the chemistry of rain. But when you look at the chemistry of even the ocean water or the freshwater systems, you're seeing these sulfates, which are dissolved salts, ionic salts, being pumped in nonstop. This is nonstop. This is not something where it's like every billion years, We're not talking about that. We're talking about a nonstop regulating system that's constantly producing these into the ocean, right? Into the freshwater systems. And so understanding and knowing that side of it helps you get a better understanding of what inorganic versus organic really means. Because you don't just have one type of inorganic material, because salt is considered inorganic because it doesn't contain carbon. So you can have a rock form of inorganic, or you can have a salt form of inorganic. Plants will always respond quicker and better to salts if you have them in the right form. So obviously, if you have toxic chemical salts or you put them too high, and any salt can be given too high to plants. So it's really about making sure that it doesn't mean more is better. That's not how salts work. Salts are something that you should have in pretty much everything you consume at a small quantity. And you should have a complex of salts. That's why people use Himalayan sea salt, right? They want more of a complex salt than just your basic table salt. which is
even though
not
it's in a chloride state, right?
Yeah,
So,
yeah, but I wouldn't say that. See, that's
no, I
where
know, I understand.
yeah.
I'm just referring to the form versus state. You know, that's all.
Yeah, and also salt is the oldest known currency to man. Salt is the oldest known. Rome used to pay its debt in salt. So understand salt a little bit more and the term inorganic from its basic scientific sense versus organic. And to deny salt is basically to deny what's the most abundant thing we have on the planet? The ocean. So therefore salt, right? When we look at the combination of the minerals and the available elements, we have the water and we have salt and then we have dry land. But the ocean is the most. And the freshwater systems are on every land. And what are feeding those? What is making the salt possible? But salt has been used since, as far as back as we can go in terms of economy because of its capabilities, its ability to preserve life or preserve living things, whether it's food or your water. It's a very important misunderstood or I guess you could say, we're not very educated. Doctors get like 1 credit hour, medical doctors, on salt, water, minerals, and the whole entire thing. 1 credit hour. Yeah. So they don't know anything. They're not teaching you anything about water, salts, and minerals. And the stuff we're given isn't the best. It's usually byproduct stuff or isolated, simple byproducts that they just give us because that's cheaper and easier and they can sell their byproducts. But that's essentially what we're dealing with in the modern day is from the industrialized revolution, taking hold of all of our ways of life is just, do what seems to work the fastest, the quickest without really doing any long-term, and whatever does, just add it, like killing bugs or pesticides or, synthetic isolated nutrients or synthetic isolated minerals. And like I said, all minerals, even your bag of dust is synthesized by man. It couldn't have got there in a bag of dust unless man had his hands on it. So technically, by the definition of synthesize, that's what that is. And, we've synthesized everything. And that's basically our existence here is to take earth material and synthesize it. So it's kind of like one of those terms I kind of laugh at a lot of times, but just because the definition really is just.
So I wanted to touch real quick on David Bryden's comment. He said that he's collecting rainwater. David, make sure that if you end up getting these minerals, add these minerals to that rainwater, and it will keep it good forever if it's stored properly. So it has the ability to activate the oxygen in the water. And what that does is keep anything that would take over the water, like anaerobic bacteria, so on and so forth, at bay. And it keeps those oxygen levels at bay in the water forever, as long as it's not, reintroduced toxins, or if it's, stored in a hot place, stuff like that, or in direct sunlight. So definitely want to add these minerals to all of our drinking water as well. If you're storing water, rainwater, any type of water, add these minerals to it, and you'll be able to keep it fresh and drinkable for a very long time.
Yeah, my humidifier reservoir gets slimy once in a while. It sounds like a good fix for that.
Yeah.
And I do want to address a specific topic. He mentioned anaerobic bacteria.
Real quick, Matt, real fast.
Yeah.
They asked where they can get it. You can get it over at dropsbalance.com. And then make sure to make a comment in the section that you heard about it from this show. I will include something in your order for your customers as an extra bonus. I'll make sure to text you and give you some options or something.
I did want to add a disclaimer about the anaerobic bacteria, because in order to claim that you kill anaerobic bacteria that harm humans, you have to have a license from the EPA in the form of a pesticide. And we haven't made our product into a licensed pesticide and got the EPA license for that. So I just want to make sure that's clear. We don't make that claim. We don't market that claim. We're not making claims on killing viruses or bacteria. The results may say otherwise, but we implore everybody, don't make the claim, even if your results do say otherwise. We don't want any, we're not trying to get in trouble with any agencies here. So we want to make sure loud and clear that we don't classify this as a pesticide. We don't make the claim to kill bacteria and viruses.
Gotta play by the rules, man.
We're in the clean water business.
And that's what plants really need. You know, they need that clean slate. And it doesn't, this is what's great. It doesn't matter where you're at, right? If you're doing strictly hydro, it doesn't matter in rock wool, it doesn't matter in, you know, full living soil system, aquaponics. I mean, water is the basis of what we're doing. And so just to be able to sit there and you can, I mean, you can get as nerdy as you want with it, really, it sounds like, right? You can structure it how you want to fit the system you're running.
Yeah, absolutely. You know, we are, when we're born, when we're born, I think we're like 90, is it like 92% water or something like that? When we die, we're 80% water, right? Our entire experience in life is a reflection of water. That's our makeup, you know. So
we mirror our water.
We mirror our water, right? And if you want, just, you know, if you want a healthier life, if you want a more pristine life, if you want better plants, you know, you have to think about what you're introducing to your plants the most often, most consistent, right? It could be the sunlight, it could be the environmental air, it could be the water you're giving it, and you have to kind of like start at whatever the plants are in the most of the majority of the time, because that's what's going to make up the majority of its structure throughout its growth, if that makes sense.
We just need to really just go fly over Flint, Michigan with this kind of stuff, right? And, you know.
Yeah, there's been people that because I actually live in northern Michigan, and I know several people who've been working with us. Gardy actually lives in Toledo, which is just south of the border. But we have churches and things that have gotten the minerals and have used them and worked with it in Flint. But in the end, it's, you know, it boils down to this. Is it the system's job or is it our job? Right? Like, as an individual, who's supposed to take care of you? You or the system? And so really, I think there's a certain mindset that one needs to have in order to care about their personal health, the personal well-being on their own accord, on their own form of education, their own form of research for themselves, versus just putting your hands in the hands of the system in every way aspect of your life. And obviously we can see that more now than ever, because digital age has changed everything. The ability for us to conform, the ability for us to rebel, or whatever it may be. But in terms of education, it's really the guided, what are you educating yourself with? What are you learning? What are you knowing? And right now, there's never been a greater time to find important information than there ever has been. But most people are wasting it by not looking into the greater things and getting to the greater, portions of your own life, your own personal journey. Is that once you start learning stuff that's about your daily life and your daily walk, whether it's with plants, animals, humans, you begin a process. And water has been one of the things, I think, everybody just goes with tap. I mean, you either buy bottled water or it's like you get tap water. Most people at a restaurant will drink the tap water they're reserved. And you have no idea what's in there. There's all kinds of crazy chemicals found in tap waters these days. When I first started in this 20 years ago, they were trying to desalinate San Diego's water because they found number 2 things were bloodworms and toilet paper. That's that's the stuff you're showering in and drinking and using for your Kool-Aid and cooking your rice. So, I mean, I think there's like this missing link that once humans get to that point where they realize, hey, we better do something about our water, it's probably already too late, but there will still be people that come out of it. I'm talking about for the greater system. I mean, Rome fell because of its waters. Anytime you see, like, America started out with Ponce de Leon landing on Florida saying fountains of living water. He called it like the fountain of youth when he stepped ground. There were so many springs everywhere. This whole country was filled with springs all up and down the East Coast. But now there's like no vital spring in the whole entire state of Florida. There's not one. They have to go to Georgia. Yeah, it's like they're almost dead.
The water there is disgusting. They have the worst water in the country. Florida does. It's so bad.
Yeah, and water, change your water, change your life. I mean, the biggest thing we consume or should consume is liquid outside of breathing air. And, you know, what kind of water are you drinking? Is your water harming you or is your water helping you? I think that should be everybody's main concern when it comes to their own well-being, especially just staying healthy, you know?
Every time you pick up an apple, the one you're eating right now, I hope you think, what did they spray on this apple? You know, like what type of soil did they grow it in? What type of water did they provide to it? How many heavy metals did this plant bioaccumulate? Right? Because none of the testing's been done.
We try to be very conscious of that for sure, because we use these in our compost as well. You know, as our plants that we grow are bioaccumulators. You know, those are all very important things for sure.
Sometimes I forget how much I'm talking about. Like the cannabis industry really is the growers. A lot of them. You know, the living soil guys. They really are. I mean, they're the farmers of tomorrow, man. They're the only people that care enough to want to take over the lands once they're. Yeah, because the big ag farmers, they actually don't even have the generational knowledge anymore. You know, it's all.
They'd save so much money. They would save so much. It's crazy. I mean, I live right here in Connecticut, Rhode Island, and it's you know, ag city over here. You know, just fields and fields of monocropping corn, and
yeah, it's like that up here too.
Yeah, you know, you smell them, throw the manures down and stuff like that, and it's
And
how much of that corn is GMO or Terminator X seed corn? That's a good question, right?
Majority of it is. You try to look up like a good, and then you got all the cow farms around here, and then you got, you know, it all adds up, and you try to find clean, you know, fruits and vegetables and stuff, you know. So you got to find these old family-owned orchards, because even if they are saying organic right now, like what's their soil like previous? What are they still bioaccumulating from previous generational use?
We've transferred over the responsibility of growing our food to larger corporations, and it's going to take time to get that type of responsibility back into the majority of people's hands. Although the minerals are a solution for that the problems that are coming from big ag in a large way. So even if we did transfer over that responsibility, we still could encourage them. Your network is your net worth, right? In a large enough room, if you asked a question to try to meet Michael Jordan, at least one person would be like, yeah, I got a cell phone number. Here it is, right? So it's just about our networking, our power of just being like, hey, you know, you're hearing the problems, like I might have a solution to that. And then hopefully it gets large enough to the point where maybe big ag, or we start to create a demand on big ag so that they look for a cheap enough solution, because the minerals are really a cheap enough solution. The larger they get ordered, the cheaper and cheaper and cheaper and cheaper and cheaper it gets, you know, and that's how it should always be, right, in manufacturing, right? So it's a real solution for big ag, for industrial problems, anything that uses water for its industry, for processes. It's a solution.
I know Matt's explained this a couple times throughout the episode, but you want to break it down just real quick, elevator pitch. Why does it work and how? You know, what does it consist of?
So your quick elevator pitch is that it's an ionic mineral solution from mica that has the ability to precipitate and flocculate inorganic and organic contaminants that become inert and insoluble. So essentially it's rendering harmful chemicals inert, and it's also keeping the water fresh. Hold on, let me just finish this. It keeps the water fresh. And that, as a result, the water stays good for a long time. So when your water is actually able to maintain its freshness, that's the key. And so you can store this water for a long time, or you can store the minerals. The minerals don't have a shelf life. So you can also store the minerals and do this to any fresh water source. And as a result, I mean, the last thing I would say is, as a result, you have water that actually gives life rather than costs life. Yeah, life-giving.
So, Derek, the chemical process is based on nature. And when you have chemicals that are in man-made, let's say synthetic chemicals, they're in a much weaker bond than the minerals in nature. So what these minerals do is they go in and they break apart those weaker marriages or bonds, and they separate them and then reattach to make a stronger bond to things like sodium fluoride, which creates calcium fluoride, which is what's found in nature. Matt mentioned hexavalent chromium converts to chromium 3, which is what is found in nature and not toxic. So besides the oxygen levels, you know, doing what they do, which we can't talk about, it has the ability to make different, stronger bonds with the toxic elements that are in weaker bonds and convert them to an inert state.
Well said. Very well said.
Oh, this is absolutely great.
But really, honestly, this is like the most exciting thing for the pot industry because of what it does. I mean, it's just so incredible, the end product. There's nothing like it. It's just immaculate. So I've seen it through and through and have had experiences with it, and there's really truly nothing like that. I'm not saying that. I don't, you know, to just say it. It's the truth, Ruth, and I'm sticking to it.
Well, I mean, that's the thing. I just moved up here from Chicago, and the water was all right. It wasn't the best, right? You know, but up here, it's just been a battle.
Yeah.
Where's up here?
Connecticut, Rhode Island border, basically. If I leave the driveway, I'm in Rhode Island.
So you have municipal water?
We're using well water.
Oh, okay. And what is it high? What is it high in?
I need to get the actual report, honestly, but I mean, pH is damn near 8. You know.
Yeah.
So it's so funny. You're going from a city, right, over to, you would think, like Rhode Island. You know, like I'm going to trees and nature or some shit, and you're like, damn, my well water is all fucked up. Right? What's going on here?
It's, you know, we have a lot of flooding right now. Shit.
Holy, got no shortage of water. That's for damn sure.
There's my rainwater.
That's hilarious.
So yeah, I mean, we usually have a nice pond over here. You know, now we got it. Yeah. So it's been great adjustment
here.
You're in nature.
Yeah, for sure.
Yeah, so for like coffee and tea and anything water-based as far as drinks, Benjamin, it brings out the flavor like 10 times. You'll never want to go back to any other coffee or tea. In fact, if you know you just had these minerals and you go to like a restaurant with anything water-based, water, lemonade, coffee, tea, blah, 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 you can add these minerals to that and it will render inert these toxins that we're talking about, which is most of the toxins that are in our tap water these days. So yeah, it's makes things taste much, much better. I've not done it in beer or brewing, but I have someone who's experienced experimenting with brewing with it right now. But for different beers or different recipes, the water has to have different mineral content. It's actually pretty interesting stuff there too. But
I actually did it. I did a test with Beard's Brewery, and they have their light some beer, but they've, you know, these milky colored beers have become popular. So it had like a milkiness to it, the color, but it was golden like cloudiness, I guess you call it. And they used the mineral side by side with the same batch, and they sat me down. They're like, "Which one do you like better?" And in the end, because it was, you know, their specific blend, or every beer brewery has a craftsman that's got his blends, it actually made it clearer, more brighter, but you could taste all the flavors way more crisp and way more pronounced. They weren't muddled by the cloudiness. And they ended up not doing. Yeah, it was pretty wild.
Real fast. Sorry to interrupt, Matt. Just real fast while he's on it. If you clicked on the reviews on the left-hand side of the website right there, if you checked out Drops Balance or PerfectGardens.com, it's right to the left on the blue tab. To the left on the go down right there. It's be the first. Can you exit out that? Normally, oh, you know what? Actually, can you go to the home screen real fast? Because the reviews are always connected to the product. So, and then now hit the reviews. You can check out what everyone else is saying. If you went over to the Perfect Garden side and checked out this product too on Drops of Balance, you would see another 100 reviews. We've never got less than a 5-star. You know, please, if you want to be that guy, go ahead and be that guy. Okay.
Clicked on the right one. Natural well water.
Oh, right there. Boom. Just you can see everyone's talking. They're talking. I'm using well water. I'm using tap water. I'm using city water, municipal water. I was using RO water. Now I shifted to tap water. You know, like read what they're saying. They're posting the pictures. They're posting the products. Hopefully, at some point, we actually have a program. It's not officially started, but our goal is to, with a few growers, maybe 50 or so, to actually start paying for the testing of the before and after on controlled group versus after group, and we pay for the COAs and on all of the testing because we want repeatable results, right? So that's a program we're hopefully saving up to do that and further bring more evidence.
I mean, whoever is lucky enough to take this on for the first time that has a big project going on, they're going to be pleasantly surprised with the end results, and they won't go back. So, and I can guarantee you that, you know, that's just the proof is in the pudding. So
I love it. I love the diversity of people that are able to use this. It's not just geared towards one person.
And not only that, I do want to say this because I live on a kind of like one of those self-sustaining permaculture type farms. We're building it to that at least, and we just planted our tree orchard. We had this 40-year-old tree. It was an apple tree when we first moved in, and so Japan was like, well, if you take a tablespoon of their research shows that if you take a tablespoon per gallon of water in a 5-gallon bucket and dump it at the trunk of a tree of a apple tree or any fruit tree for that matter, that you'll see more blossoms and way better fruit the next season. And so I did this to a 40-year-old apple tree that was ready to go. And my wife's like, get this thing out of here when we moved in here because it was so old. It wasn't producing. It was over, like, just not in good shape. And I did exactly that to the tree. And this year we had, so I could send pictures. I'll have to give Mark pictures that if anybody wants to see. There's a crazy amount of blossoms. That no apples fell off the tree. Like usually you have apples falling off the tree by mid-summer or late summer when they're developing. There was no apples that fell off the tree, and we were picking through the first frost in mid-November in northern Michigan. Fresh apples that tasted amazing. I mean, the taste, hardly any spots on any of the apples, and we didn't use any sprays, nothing. We did nothing new. We just did the dump at the base of the tree. I have cherry trees being tested out in California right now, a whole row of them on an area that has very old trees that's ready to go. And they much younger than my tree, but you know, they get rid of them after a certain age because they don't produce as well. And I think that's an important part of, you know, your food, the food you get, you know, your garden, everything you're producing. You want it to be as nutritional, you know, as much nutrition as you can get from it. The more the merrier, and purity. I mean, having good fruit that you taste, you're like, dang, that was a good one. I wish they were all like that, and everybody's had that. Everybody has had that. If you've eaten a lot of fruit in your life, less now than what it used to be like, but when you get a hold of a good fruit versus, even if it's the same variety, you know it, and you can tell there's more nutrition, there's more flavor. It's the same thing with your cannabis. It's just you know it's there because you can taste it, you can smell it, and that's what lets you know the cannabis that you like the most is usually the cannabis you can taste and enjoy the flavor and the effect the most. And so in the end, that's what you're getting in your apple trees. And we're, like I said, we're testing old cherry trees. We're doing that right now, but we're also in the process of getting a lot of people involved in that now. So, and when people understand, hey, I can get better nutrition, use less chemicals and products to try to defend everything, and allow the plant to do what it's supposed to do, and still stick with the same feeding regimens, and still, you know, master your inputs so that you can get optimal results. This is the cutting edge. You know, that's the cutting edge.
I love it. I think that's great.
Guys,
so people are
yeah.
asking about like let's see here.
Guys, in 12 to 14 days, challenge this in 12 to 14 days. You'll see it. You know, you'll see it. You'll see it. You'll notice it. That's all it takes, you know, 12 to 14 days.
Yeah, we can't answer any questions about bacteria, unfortunately. And I kind of already went over that. Without killing fish. Yeah, well,
we do have an aquatic testing, an ocean testing, freshwater testing. It's non-toxic to fish. It can be used safely. It's mineral salts are added to tanks all the time. In fact, you can't have fish tanks survive unless you put mineral salts in the water.
Show Holla what you got your fish tank one more time there. That thing is pristine.
Well, someone put on there and they got removed, but they're like, "Oh, you just changed that tomorrow." I mean, I've been doing this, Matt, for how long? These fish aquariums.
He's been telling me that he wants to come out with some. This is over a decade that he's like, I need to come out with a fish aquarium product. I'm like, do it, and he's just never done it. So he's had his other brand, but he does the drink more.
Tank, so.
But he's always bragged about how it's only like a month. I mean, since I've known, he'd say he'd clean it once every month or two.
No, not even. Yeah.
It would. Yeah, I mean, I don't know. You've been doing it. I don't have a fish tank. I'm not going to speak on his behalf, but that's just like kind of what I remember for the last 10 years. I'm always reverting back to his fish tanks.
Guys, a 2-ounce bottle is good for the plants for 60 gallons. You know, it's good for 15 to 20 gallons. Go pour it in a fish tank, right? Watch it. Call us out. You know.
Well, I want to say this. I want to say this because this is pertinent facts to why we should even talk about this. In Japan, sushi is a big deal, right? And so the originator of this technology, he used to raise his own eel and freshwater and saltwater type fish for sushi. And one of his comments, one of his information, his data that he found when using this product with raising freshwater eel was that he was able to produce 100% or 99% top grade meat. And what happens in the sushi industry, and especially in any seafood type food, is you're paid based off of quality. So when you get the cuts of the meat, if they're poor quality, you get less money. And especially with eel, it was considered 1/7 of the actual eel would be top quality meat, where he was producing eel in his own tanks using these minerals, getting 99%, meaning all the flesh in the eel is good. So you have no waste. You have no byproduct waste, and you're getting top dollar for the entire eel. And that's something we haven't cracked into yet, but that's something I see as a possibility, a great possibility in the near future for funding or people to start getting into using this with fish farming and aquaponics, growing vertical gardens, using our resources more wisely to produce food, healthier food, more sustainable food.
Hopefully, let me try one last thing just to maybe sum this up. Right? Is even on the most smallest, tiniest level, we don't take true consideration of how toxic a stagnated molecule could be, that molecule being water, right? And so even in fish that are pumping in the oxygen in there and all this stuff, if the water can't hold the oxygen, it's under-oxygenated, right? So it becomes toxic water. The meat, all these things holds oxygen, it holds water. We're made up of water. So as we hold on to this water in these tissues, if that water is made up and it doesn't have minerals or isn't capable of holding on to oxygen, that water becomes stagnated, and at that point it becomes toxic to the fish. It becomes toxic to the soil biology, everything across the board. And and that's about it. I just hope that kind of we understand on the smallest, tiniest of levels. We see that even with the eels, right? It's like more tissue being available. It's because all of the tissues are living in an oxygenated environment, and none of the water is becoming stagnated and toxic, even in the cellular tissue of their meat.
I do want to. Let me add one thing to that, if I could. Let me add. I'm sorry. Let me just say that the one thing that we haven't discussed on this call, and one thing I would like to bring up would be that this creates what's called H3O2. I mentioned that, but it's also known as plasma state. So water has 4 states, or the 4th state of water, 4th phase. Water has 4 phases. It has liquid, solid, gas, and liquid crystal state. Your liquid is your regular H2O, your gas is your vapor, and your obviously your ice is your solid state. And then when you get to liquid plasma, there's only 2 places those exist naturally in nature. One place is inside the cells of animals and plants. So inside the cell wall, you have liquid plasma. That's why they say, oh, drink raw juice. It's like liquid plasma. Or inside your cells, intracellular fluid. The only other place you find it in nature is in vital springs and at the bottom of the ocean. So this, in fact, the sulfates used at the bottom of the ocean by the animals or organisms or whatever you have down there, because most of the life, remember, is at the bottom of the ocean. The majority of it's hard to think about that. We have so much damn stuff going on the surface, but there's way more life at the bottom of the ocean. When we think about that, well, what are they living off? Well, they use the actual sulfates as sunlight replacement energy. And how 4th phase water is identified is by its ability to absorb UV. And so when you're looking at 4th phase, it has to be able to absorb visible UV just before invisible UV at a certain frequency, and then you know that the water is that. So when you use these minerals, you are putting the water in that state. And so obviously through contamination, or if the contamination is greater, it's the discretion, especially for drinking water, of the person with the minerals of how much to add. There's a basic way to use it. And then there's, okay, I know this water is like horrible and I'm surviving and I need to add the adequate amount. You would up your dose and add more at that point. And there's tests showing that based on raw sewage, because you can use this for raw sewage treatment, there's 3 times as much, there's 6 times as much, and 9 times as much they have used based on the level of contamination in the water. And putting the water in that state, or getting to accomplish that state, is going to be based off the other variables of that water outside the water itself. If it was distilled or reverse osmosis, very easy, happens right away. If you're dealing with raw sewage, it takes some time. You might have to wait and let it sit for a day or 2 to do the process. You might have to add a turbulent, something to mix it, something to, oxygen bubbles or something to speed up the process. But in terms of, using it for yourself in basic fresh water, you should get the results rather quickly, or you should be able to safely drink water. I would just use your discretion and know that the technology is based off of what we see in nature happen in only certain places. So if we see that state, what we're calling the plasma state, and it affects the plants, it affects the fish. We're seeing it in the fish tank. Gardy obviously has his fish tank. I don't have one, but I've seen it. I've gone down to Sandbloss Islands and taken water that you couldn't see through the sun, and treated it, and it could get crystal clear.
After 15 years, I'm still waiting for the product to not work. Right? Like I'm not a skeptic, but I am definitely someone that, I've been shot in the foot. Sometimes things are too good to be true. I get it, but I also have learned to realize that there are some products and some things created by artistic people. And then there's a lot of other products created by sociopaths and psychopaths. And when you find those products and those services that are created by artistic people, they end up becoming a benefit to our society. And for me, I'm just a preacher, right? I'm just preaching the word, right? I'm just preaching the information that has existed for over 60 or 70 years of my life, from a person that I got God forbid. I think he's already. I think he's over 100 years old at this point, and that discovered this one in his early 40s. And I'm just, in a sense, I had to use the bigger words, but a disciple of that information and trying to transfer it in to more people, because it's quality. It's been quality. It's been consistent. 15 years. 15 years has been that consistent.
Okay, Matt, real quick. What is the Dr. Pollock for fourth phase, right?
Yeah, he's from Wisconsin. If you look up Easy Water, it's called, or Dr. Pollock, you can find all kinds of research and information on his discoveries.
Dr. Pollock.
Yeah.
Also, Mark, do you have an MSDS? They were asking.
Yeah, I'll make sure to make it available if it's not on the website already.
Okay.
We just updated the website, so.
And then I'm also getting asked. They're asking what the main ingredients are. I put water, then sulfate minerals, and they're asking, Matt. So sulfur is like the main thing. Do you want to go into that a little bit for him? About
the sulfur is about 5% of the total solution in the raw material state. The other 25 to 30% would be your mineral salts. So your iron, your aluminum, your magnesium, you're all in the order in which you would find it in the stone. The only thing that doesn't dissolve is the silica, because silica, it's like the undissolvable stone. That's why you have the only thing left on your beaches is sand, right? Because it doesn't dissolve as a part of the salt. So you have the silica left as the sand. But in the end, it's just what comes out of the mica, and that's basically it. I mean, there's really, in terms of the contents and in terms of the sulfur, the relationship is that the sulfuric acid is used to ionically charge, just like a volcano would, to create the sulfates, which would be the minerals charged with hydrogen and an additional sulfate as a result. There's nothing else used. There's no other additives, or we're not formulating. It's more of using an extraction process of a stone that's been formulated by volcanoes. That's the best way I could explain it.
Yeah, so I mean, there's just a lot of questions coming in, and I don't think we're going to have time to answer all these.
Pick out ones that you think need to be answered.
Sure. Do mineral salt ratios in the raw material differ from those in seawater? If so, how? Well, we've already covered that.
Well, let me repeat that just so that everybody who maybe got on later or whatever is, as the salt is created as sulfates in the ocean, it percolates through the system. And just as when you add these minerals to water, there's going to be a different result left behind based on what is in that water. The sulfates from the bottom of the ocean, as they percolate through, exchange with life. So you don't have a sulfate all the way at the top. You have chloride, but that's after all these sulfates have interacted with life around it. It's just like as when you add this to water, you're interacting with whatever's in that water. So as an end result, you might have chromium-3 instead of chromium-6, or calcium fluoride instead of sodium fluoride, or whatever else. Bonds can be exchanged as a result, and the process leave behind.
The minerals are completing the chemical reaction, right? So you're dealing with incomplete man-made bonds that are not natural to nature. And these different bonds that have a different level of toxicity, but either way, when you accumulate too much of them, they will, no matter what, become toxic. And the minerals dissolve those bonds. They were talking about the covalent versus the ionic. So they convert these weaker bonds back to a sulfated, naturally occurring bond that the bacteria and that us as human beings can process and are natural and do not become, well, anything becomes toxic at too much, but they're in a form that is most natural to our life experience.
Well, I want to also touch on, because it's like, I really want to point out, and this is what the scientists that did the experiment pointed out, is that your heavy metals, for instance, or your sodium fluorides or whatever it may be, can be in a dissolved state. And so when you have an ion exchange, more often than not, those chemicals, they don't change, they become insoluble. So like calcium fluoride is not dissolved, it's insoluble, just like, well, what he thought pre-proposed that was happening is you're not getting rid of the heavy metal, so to speak, but it's no longer bioaccumulative. It no longer has the ability to be taken up into the material anymore. And so I think that was, you know, a good lesson to learn with the product and the state that you're working with, which goes along with the chemistry of the ion exchange, is you're having deposition and agglutination and flocculation take place, which is where those harmful ions that are dissolved, that can get right in the system, that are byproducts, are being converted over into insoluble ions that can no longer penetrate the cells, that are being rendered out of the water and sent to the bottom. And anyways, that was all I wanted to add, is the insoluble versus soluble, so that people can understand what you're seeing. Because when you add this to your water, you're going to see stuff come out of your water and sink. So understanding that you're seeing insoluble things become soluble before your eyes, that's important to know that. And you're going to have questions. What is this stuff? Well, that's the stuff that's sinking out of the water, those contaminants that you couldn't see with your eyes, that looked like they were part of the water, which they were, yeah, but they become out of the water. And now you can see them visibly.
It's the truest way to look at purity levels of any fresh water, because
and distilled and reverse osmosis water will not have it.
If there's something that's laden in the water, dissolved or not, that's not supposed to be there, it's going to reveal it and make it fall out. And in the end result, it's not water that rots, it's the organic matter in the water that rots. And that's what it removes. So in the end result, you're getting pure water. It's like distilling water, but giving water back, restoring it back to what nature intended our water to be, with the proper minerals. And that's life.
You're going to see that at 5 mLs per gallon. At 1 ml per gallon is what we recommend for soil, for water systems for your plants. You'll more than likely won't see it. And you'll see that reaction over a 24 to 48 hour period for drinking, but you don't have to wait that long. It's just to see those results, that once you put the minerals in, they start doing their job. And then it completes those chemical reactions over a 40-hour period, but for drinking at 5 mLs. For plants, you just put it in there and it starts to do its job. You don't have to wait. Just make sure the pH is under 7. That's what we really stress. You have to make sure it's in an acidic form. If it's alkaline, it will make the minerals inert.
Now, I do want to recommend, based on your 8 pH water, you know, especially for your plants, you're going to need to adjust your pH. I would almost say add the minerals and then adjust your pH afterwards, and wait till it's actually adjusted, because what you're dealing with is essentially a lot of CalMag, and that's going to kill your plant. It's going to be too much. The alkalinity won't let anything else absorb, and you need that CalMag to become absorbable. And the only way you can do that is calcium and magnesium dissolve very easily in acid. So when you get the stabilized, everybody's who's messed around with pH of water, if you've done it long enough, you know that fluctuates, especially when you have other elements in there. So like if you pH the water right now and it goes down to right where you want it, when you wake up in the morning, you check it, it's going to be back to alkaline. You're going to be like, dang it, I thought I had it, now it's back to alkaline, and you tested it again and saying, maybe that's my problem. Yeah, that is. So really, to stabilize the pH, you need to let the reaction take place. So as the hydrogen's dissolving your calcium and making it, so it's more of the hydrogen taking over than the calcium that's present. Once you've reached that equilibrium, your pH will stabilize. That's the best water to give your plant.
That's interesting, yeah.
You know, if you're dealing with high alkaline calcium water, because now that calcium becomes absorbable to the plant and isn't locking out the rest of everything else with the high pH. So minerals are either alkaline or acid in terms of by them elements. So elemental calcium gives a alkaline pH. But again, calcium can be dissolved, much like CalMag solution, into an acid and made into a neutralized, but it's still a pH of alkaline element. And so when you dissolve in acid, and acid is the electricity that makes the plant, the element gain life, the mineral. So CalMag gains its life through the acid and can be absorbed right into the plant bioelectrically. When it's dust, or it's just that stuff that is on your, probably experiencing in your dishwasher or on the side of your, that stuff can cause all kinds of problems, because it's going to react with your skin, dry your skin out, give you dry skin. And also it would dry up the plants. It would suck the moisture and the acidity right out of your protective acid that your body creates. Your skin, which is your largest organ, is like a 5.6 pH. It's not an alkaline. If you put soap and alkaline things on your skin, it's going to dry out right away. So that's one thing I would say that you have to understand about calcium in water, and it shouldn't be that high. And you do have to neutralize it. Use your pH down, stabilize it, get it to where it's reading right where you want it for several days, and then start adding your inputs, or get it at stabilized at 7 at least before you start adding your inputs, depending on how you. Yeah.
We are unconsciously being indoctrinated into their world of petrochemical fertilizers and
ran by NPK system and just absolutely. Yeah.
We got to really look at this problem with a new set of eyes. We can't just be allowed the marketing and these larger corporations to just keep teaching us. We really do. We just gotta.
Well, you know, Mark, that nature has the answer, right?
Absolutely, it has the answer.
Nature's always had the answer since the beginning of time for our water and our soil and our plants, right? But we don't follow nature, do we?
Well, the system is built to self-sustain already. It's not like we as humans need to interfere for it to sustain. So the model's already been built or made, or it's already here, however you want to look at it. And it self-sustains itself.
Guys, also, after 15 years, this conversation hasn't stopped with us because it only keeps getting more intense. So you guys let us know when you've had enough, because it just keeps getting, I mean it keeps getting deeper and deeper and deeper. You start to see water and how our ancient ancestors and our cultures throughout the world has used words of affirmation and water. We're talking Dr. Emoto was water, where they talk about love, 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 and water. I don't know if you guys seen these experiments. We're talking on a higher level consciousness of water, and the deeper you go into water, it's going to go farther and farther. So just let us know when you feel you've been saturated enough, because really, I mean,
there was a question about memory in water that was on here and what it does for the memory of water. Matt, do you want to go into that, Doctor?
Yeah, so I'll go back to the very beginning. Like a mirror, I said water's like a mirror. And so when you look in the mirror and then you walk away, you're no longer seeing a reflection of yourself. The reflection's gone. So water cannot store energy, but it reflects the energy that's in it or near it. So for instance, if you're in water, I'm going to give you a good example, or several. If you're in water and lightning strikes, you get electrocuted. But if you're next to the water and lightning strikes, then get in the water, there's no electrocution. So water never was charged, right? The charge ran right through it and hit whatever was nearest thing that it could grab a hold of. You being maybe the person if you're in it, which you don't want that to happen. But in terms of what's in water, and there's where we get to the salt, and you look at the ocean and the natural fresh waterways, that's the true energy that's a part of the water. So water, in terms of fresh water, ocean water, will never be just water, ever. And even rainwater will never be just water. It's always has something in there charging it.
Let me add one detail to that real fast, Matt, is you got to think about this as a mirror, what he was saying, right? So you have this pristine, perfect mirror with this amazing reflection. And that's what the minerals do. It creates this perfect mirror of reflection, versus when you add all these other chemicals in, you have all these rivets in the mirror and you can't really see very well. And you look into it, you can't really distinguish the reflection. That's what happens, right? You're putting back this pristine reflection so that whatever state of mind you're in, your water is going to reflect that state of mind, that world. Okay.
And it can be physical. It doesn't have to be metaphysical, because when you're looking at a bag of shit in water, it's a bag of shit in water. So if you fill up water full of shit, you're going to have physically looking, smelling shit water. Yeah. So the idea is like, well, whatever energy is dominant, whatever substance is dominant within that water, the frequency, the energy, the water will respond to it. The water will reflect that energy. But how do you get, and what Mark is talking about, how do you get that energy? And the minerals is what we found, the only thing that really does it. I mean, we haven't found another product like this. It's not like there's like a gazillion of these products on the market. You can buy them here and there. They're cheap from China. It's not how it works. There's one place that this comes from, and it's the lack of, I guess you could say, of necessity. So we're at a point of where necessity is taking over in this area, which leads to a greater movement in the understanding and development of it, which has always been there, but it's just our findings. As humans, we go through phases of discovery and phases of how to work with the material on Earth. And there's always a new era or a new way that will lead to better results. And it always leads back to what you call the primordial or the essence. But that frequency is what's being portrayed in the mirror. So that primordial frequency, which is an ionic charge that in chemistry has a greater bond than your covalent charges and your less, what you call man-made charges, that will have to bow to the chemistry of the greater bond. And so in the mirror, you're going to be reflected what that is giving rather than the other energy or the other frequency can reflect in the mirror. And that's why I call it a mirror, because the water will tell you. So if I take shit water and I treat it with these minerals, make it crystal clear, no longer are you looking at shit water. You're looking at the reflection that the minerals gave the water. And so I wanted to give it in a more like physical, that you could see and actually get results rather than us. And that's why I'm making sure that is known in that regard, because it physically is true and possible that you can do that with this. So that's a test anybody can do, but you would have to make sure that you're doing it, obviously, scientifically or whatever. If you're trying to really get the good results, do it in a right way. But I don't recommend that we start with the worst water to get the best results. I recommend that we start with the water that's best available to us at wherever we are and bring it to the best state so that we can then utilize it for everyday use. Because in the future, we're going to have to. There's no doubt about it. We're in a different place. Like, if you don't fix your water, no one's going to fix it for you. It's getting worse, not better. It's not like they're announcing to you some bills that they're fixing our waters. They've known about, you mentioned Flint. Which one of you mentioned the Flint? But someone mentioned Flint, and, what have they done? Who's put in it? So I think that the biggest thing is it's like, okay, well, it's your responsibility as an individual, because shouldn't you be responsible for what you put in your body? You're going to blame everybody else for that? That's why I look at it.
That's why we're finding a lot of these illnesses and even things like dementia, right? And a lot of these inflammations cause
modern day illnesses are a result of mineral deficiencies. When we look at a plant, every time a plant has a symptom, what do? We always go to a mineral deficiency chart to correct the symptom. We're the same way. We're elemental beings, but instead of giving us our mineral deficiency chart, they give us chemicals that make us sicker, and so go on and so on, right?
Absolutely.
What were you saying about that? You were going to say something. I think you were going to make a point.
So right here, if you go over to the website and it's a digital book called Mineral Deficiencies. It's about an hour and a half long, and it explains a lot about exactly what you said, why people are being why modern day illnesses happen, and it's because of exactly what we said, mineral deficiencies, and you relate it back to enzymatic production and so on and so on. So, and then guys, like I said,
worth reading.
It really is, and also that's why also we have we did literally it was a $30,000 field study test. A dedicated employees dedicated to the test, pulling the reports, growing the plants, sticking to the regimen, all focused around the getting data and information. And it's something that us as entrepreneurs we're searching for, but we're doing a lot of parts of different parts of the business, right? So at times we think something's making things better, but we're not totally sure. You know, sometimes because of the volatility of the market, we try to identify how well we're doing based upon how much money we're making. Yet the statistical data showing where people are actually employed to do this was actually done by a third-party company too. So we didn't control the results. We hired a company, gave them money, and they said, we're going to provide these results based upon what we find and publish them to the public. Are you sure you want to do this? That's how that conversation went. So I just go to read the report. We'll make sure it's available to you guys. Read the report, extract the information, and hopefully, like I said, go from there, you know, because I think this, like you said, Future Cannabis Project, this was just the perfect channel to start to release this information, because we generally do think this is the future to cannabis. This is the future to agriculture, to solving the problems for pesticides, fungicides, and heavy metals.
For symptoms.
for symptoms, all of it in general, and a lot of stuff with that dealing with the state of water.
I encourage you also, everybody should have some of this. I mean, if you believe in any ounce of like pairing for your own water for emergency use, or just for experimentation and using it in the field, get yourself at least one bottle and put it to some tests. Try it out for yourself in many different ways, because there's a lot of things you can do with it. I mean, we had this lady from Hinckley take 3 potatoes, and she took, it's actually on one of our social media things. She took 1 potato and put it in her Hinckley water, another potato and put it in her bottled, distilled, or whatever it was, water. And then she took the Hinckley water and treated it with the minerals around it through the filter and put the potato in that glass. And she had 3 mason jars. And the one with the Hinckley water just rotted and turned, like within a week, it was like blue and black and just nasty. And then the one that had the purified water didn't do anything. It was still just a potato sitting there in the water. The one that had the mineral treatment had roots, solid white, growing, like tons of thick roots growing into the water. So do your own experiments. I had one doctor one time take a head of romaine lettuce and put it in a quart glass of this drinking water, and it started growing roots at the bottom of the romaine. I already harvested one that he bought at the store.
Look at the roots of your seeds when they pop out. Tap water.
Put it through some tests.
Put it through. It's $20 to know whether we're full of shit.
Another thing too, it's pretty awesome, is that you can take a glass of this water, treat it at the regular dosage rates for water, and you can set it out in the sun in a glass like a mason jar, and within about 2 weeks it'll start, well, maybe even sooner than that, but it'll start to bloom a blue-green algae. You can actually create your own food with this water because of the algae, and the algae is very, very good for you, you know. So yeah, it's very interesting.
I think we're rounding 3 hours, so I don't want to hold you guys up any longer than what you wanted. You know, we can keep going.
Yeah, I gotta go get my son from school, but you guys are round 2.
Not a problem. We'll get a round 2 up one of these days and get you guys back and let the further discussion. For sure.
For sure.
Yeah,
we love it. We love to help others with this, so that's what we're here for.
Oh yeah.
Well, we have the information in the show notes as well, people. So go ahead, you can head on down there and be able to find all the products. I think I'm gonna have to give this stuff a try definitely sold me on
Actually,
it.
I'm gonna text you in a bit. Get your address. I'll send you out a bottle. I want you definitely test it out and try it out.
For sure, absolutely.
I appreciate you very much. Thank you.
Looking forward to that, man.
I'm shipping yours today, Tyler.
Fucking right, brother. Thank you.
Use it in your drinking water. And one real quick thing, if you're using it in your drinking water to really feel the most effects, and is to try to drink half your body weight in ounces of this water daily, and give it a couple of weeks, and we'll talk then.
Yeah,
that's interesting. Detoxify my.
And then one other thing too is when you get the minerals, get a glass of whatever, tap water, well water, get a large glass of it, and then add the minerals to it, and then let it sit overnight, and then go back to it and look at all the crap that came out of the water.
Start with boiling hot water that comes from your tap water. That's what I speed up the reaction.
Look at all the shit. See, this is a batch of FICO there that I was brewing up, so I had double boiled it, and look at all the shit stuck to the outside from the water boiling off. It's just white shit. I'm like, my water's disgusting.
That's what you were showing us earlier. I got it.
Got it. I thought you were showing us the hash.
I forgot to mention anything while I was doing it there. I was just immersed in the conversation, but I meant to say, like the water's disgusting. It's got so many, I think it's calcium in it that sticks to everything.
Well, it could be calcium along with all kinds of other crap. You just don't know unless you have the money and funding to be testing for everything in your water. You wouldn't know. There's places that do $300 to $500 tests where they try to do all kinds of chemicals, but typically you're going to have a higher calcium, magnesium, and then if there is anything, it's probably going to be from natural sources for the most part. I mean, unless you're near some place that that's contaminating it, and that's. It's just the calcium, magnesium will kill it. Do not use them in dehumidifiers. Make sure if you're using humidifiers, never add. It'll leave a calcium layer on things. If you ever had that, use distilled, use RO if you have to, or bring the pH down so the calcium and magnesium don't go in the air and fly around like dust. And your fans in your house, when you boil water, you should be treating it. You shouldn't be boiling water because you'll get that evaporation of that dust into your fans over your stove. That's a big deal. It's a big deal to have too much calcium, and it'll also cause you problems. I mean, cramping and all kinds of issues for drinking the higher alkaline with high calcium water. So definitely get water that's to drink, or treat your water to a point where it's not overpowering in that regard, or you will have long-term effects from that yourself.
Chlorine. I'll give you an example. The two biggest detriments to soil biology is chlorine and chlorines. That's the biggest thing, right? For soil, chloramines. Yeah. They void the soil of us. They void the soil of bioenergy. This way of just stopping it right in its track, right? And so when you so we don't realize how fast these chemicals actually are capable of absorbing in the plant or in our body. Like literally, if you have chlorinated tap water and you put your hand in it, if for 10 seconds and remove it, it will have absorbed all the chlorine in your hand. We have videos showing these things. And it's just, so when you take a shower, by the time the water hits your toe, it has absorbed the majority of the chlorine running through your shower for that 5-minute, 10-minute, or hour-long shower some people might like to do, right? Absorbed all that chlorine. I don't want to
bring my kids swimming no more.
Yeah, it's exactly. So just chemistry is interesting. The subject goes deep. It's throughout our cultures. Thousands of years of history of water. Why civilizations have fallen because of water, and it's just something we're overlooking right now in the industry. Big time. I mean, we're looking at it with RO systems and well water, and we know of it, but we're still dedicating our time to fertilizer, lights, soil, but we need to pay more attention to the water.
Yeah, I mean, you also look at nature. If you get rain, what's in rainwater? A lot of people don't think well, what is in rainwater? It's mainly sulfates and other elements that are part of a cycle in the rain. but they're not high. They're in trace amounts. You know, you might have 3 to 5 ppm or whatever it is in the total rainwater. So it still has trace elements in there, and that's a key factor. It's not, people think in terms of distillery and RO is like this mimic of rain, but it's not by any means. There's ions that are being absorbed in rainwater before it even falls to the ground. So, and not having those ions, you can't possibly mimic it. So that's what I think we need to understand is like, what is it that we're giving? Well, it's elements, you know, in their sulfate form. Rain has sulfur-based elements that are dissolved, and that's why whenever there's a volcanic eruption, you have electricity at a volcano. That's why you'll see thunderstorms. And if you look at like the Tornado Valley and where you get all these concentrations of energy and thunderstorms, there's all kinds of volcanic systems that are constantly releasing the sulfates into the atmosphere, and they accumulate. And there's a cycle of that too. Just like there's a cycle of the carbon dioxide being breathed in and out of the ocean on large scales at different times of the year. Sometimes it's breathing carbon dioxide in, and sometimes it's breathing it out. There's an ebb and flow process, and part of, you know, knowing that with your water, that's why if you even think about it, you have the ebb and flow of hydroponics. There's a whole setting of being able to have that constant replenishment or constant frequency or regurgitation of elements, which is what volcanoes are doing. They're essentially taking all the mass on Earth and regurgitating it. And that's where the technology really stems from, that going to the primitive state. If you look up primitive state, it means the best original state. So we want our water, we want our food and our water in the best original state.
And our pot.
And ourselves, our health. You want your health in its best primitive state, because your health in its best primitive state is its best. There's no synthetic state that's going to be better than your best primitive state. There's just not, unless you're talking AI and robots. That's a different story, right? So.
Well, I got about 5 minutes to make it over to the school. I'll only be gone for 10. I don't know if you guys are still rocking or not, but
I'll tell you what, I got to wrap up myself.
Yeah, me too. I have my daughter. She's itching to play. So.
Okay. Well,
we'll get back with you, man. We'll do this again.
Round two.
Yeah.
Definitely round two. Well, where can we find you guys?
Over on Perfect Gardens TV on YouTube channel. We're starting to do our Instagram and other things now, so you'll see the shorts coming out. But for the next year, my goal is to reach out to guys like you, anyone willing to listen, to share this report. I think it gives credible information to help solve big ag problems. And my goal, you're probably going to see a lot of content get reduced on my channel for the next probably the next year. And hopefully other people are going to be willing to pick up some of this information, read the report, challenge us, and process information, and hopefully, give it a shot. Give it a shot and see in 12 to 14 days.
Proof is in the pudding.
Proof in the pudding. Yeah.
You guys have like an Instagram personally that you guys throw out to the fam, or?
Well, just the Perfect Gardens, perfect_gardens is the Instagram, and everyone's available from Gardy to Matt. Pretty much.
Awesome.
If you guys ever,
I mean, people can call me, whatever. I will
probably don't release your personal
information. Through your show, the sales will go to you. We're not here to take sales away from you. So everyone knows that the sales will always funnel through whatever platform we're discussing or sharing with. But we're here to help you guys to get that information out to others, because it's so important. So
that's why we want you guys to post. Just make sure, if you guys do go to the website, make sure to let us know that you're coming from this channel. And
you'll get a free little something too. So
yeah,
sounds like. All right, cool guys. Well, we'll do it again soon. It's great meeting everyone, and look forward to doing it.
Thank you very much for your time, gentlemen.
See you guys later. Have a good day. Thanks for having us.
Have a great one, everybody.